What is up? Daniel here with the Virtual Robotics Studio, and we are back. We've got our bumpers on, we've got our robot wired, we've got all of our firmware set on our devices, so we're ready to start programming. This video is going to be all about autonomous programming, which is the first 20 seconds of the match, where all of the robot's actions have to be pre-programmed with no driver input. We're going to get started on that, but before we do, we're going to give a special thanks to Argosy, First, Aramco, and Team 302, Lake Orion High School, for hosting our studio. All right, first step, let's get a battery in the robot. And starting now, whenever the battery is not in the robot, you probably want to get it on a charger. Hopefully you have at least 2, if not more, batteries. So we always want to be charging one so we're ready to swap to keep working. So we'll drop that in, get our Velcro strap on. All right. Can plug that in. I'll turn it on, and then I'll go ahead and reset the floor. Because remember, it takes like, I don't know, about a minute for everything to boot up. So we got some time to get stuff reset here. And while that's getting set up, I'm also going to do one more check on the whole system here. So before we were plugging in the last video, we were plugging in and doing the Rev hardware monitor for each individual device. We can do one more check just to make sure everything is set up by plugging into any device, and we should be able to see all of them. When the robot's on, we should be able to see the entire CAN bus, so all of our devices. So grab your USB cable one more time, and you can plug it into whatever USB port you can access the easiest. I think for me it was this Solo speed controller over here, Spark Max over here. So you can plug that in. And then we'll take the other end up to our computer here and plug that in. And then on the computer, I'm going to run the Rev software again. So that was the Rev hardware client. We'll run that again here. And when this comes up, we should be able to see basically 6 speed controllers, 6 Spark Maxes, and our power distribution hub all on the same bus. This is just the final check before we go in and start controlling the stuff. All right, so loading up. And you can see the one that's showing up here is the one that I'm plugged into. Again, you can click on the little light button and it'll flash. But what you're looking for is 1, 2, 3, 4, 5, 6 Spark Maxes, 1 power distribution hub, and I know we changed the ID. You did not need to do that. I did double check that, and it would have been fine if we left it at 1 because it's a different type of device. And then finally, we have the RoboRio showing up. If you are missing any of these devices, you'll have to go back on the wiring, check the yellow and green CAN cables, make sure they're connected all the way through. If you're missing a power distribution hub or RoboRio, that's the most likely cause. If you're missing one of the Spark Maxes, it's possible that when you clicked persist, maybe you forgot to click persist changes, or when you clicked it, it didn't take. So if you see like 1, 2, 4, 5, 6 for your Spark Maxes, then one of them might be not set to the new CAN ID. So in that case, you can go through this list and you can click on each individual light here, and then look for that light flashing in the robot. And whichever one doesn't flash, that's going to be the one that you're going to need to go in and work on. So remember, we have the set of LEDs on each of our Spark Maxes here. And let's see, I think, so that row is 1, 2, 3, 4 for me. So if I click on number 1, the light next to number 1, we're going to get that fast flash over here. So one more time. So you get that fast flashing on that one. If I click on number 2, I get the fast flashing on the next one, and so on. So if you're missing one, you should go through, click that light for each number, and then whichever one's missing, whichever one didn't fast flash, plug your USB cable into that one, turn the robot off, plug your USB cable into that one, and reset it up like we did in the last video. But I have everything showing, so I'm pretty happy with this. I am going to close this down. And then let's get this orange cable out of the way. There we go. All right, and now we're ready to run our programming software. So that's going to be the 2026 VS Code. And remember, there are two icons on the desktop. One is VS Code, and one is documentation. Make sure you run the one that says VS Code. All right, and this is going to pop up. There's some stuff you can choose here for your setup, getting started. I think you can completely ignore that. You can mark it done, or you can go through and actually do it. You can choose different themes and stuff like that. But I'm just going to go ahead and do a new program without bothering going through that. It still works fine. So in WPI Live, there is, or in VS Code, WPI Live VS Code, there is this one small icon on the top corner of the screen. And it looks like the same logo as the shortcut that we use to run the program. So right here. And that gets us to our WPI Live command palette. That's where we're going to be clicking to do a lot of the things with our robot. If we want to create a new project, deploy robot code, all of that's going to happen from that menu. So once I click on it, we need to create a new project. And if you start typing, like for me, it's showing up already, but it might not be for you. If you start typing create, it's probably going to be the first option that's here. And you can just click on it once it shows up. I think you can do tab or enter as well. And that's going to get us started creating a brand new project. All right. Then we're going to do select a project type, example or template. And when you click on that, up here, we're going to have our two options, template or example. Example is going to have a bunch of like code snippets that you can look at. That might be like, here's an example of how to use this sensor, or here's an example of how to do this type of motion. So if you're like wondering how to do something, you might look in the examples and see if there is an example for what you're trying to do. But we're not going to want to do that for the main program. For the main program, we're going to want to choose one of the templates. So I'm going to click on template up here. And now we can choose between two of the languages. Remember, we talked about there are 4 languages available this year. You can do LabVIEW, which is a graphical language that most people are not using anymore. Python is new, and that is a language that you can use as well. And then here in WPI Live, we can do C++ or Java. Java is sort of like the most popular language right now, so there's the most support for it. And that's what we're going to choose. So go ahead and click on Java. And now in Java, there's a bunch of different examples. If you got one of the Romy or XRP robots, these are like mini desktop robots that you can use to practice coding with. Those would be here. But we're going to go back up to the top, and there's like a few different choices. We have command robot and timed robot, and those are the two big types of code that you can run. Now, the first KitBot code that they released and their instructions for coding is done in the command-based robot. Command-based robot is probably more powerful. It's probably something you're going to eventually switch to, but it is more complicated. There's more overhead. The different actions are spread out over multiple places, so it takes a little bit more time, and I think it's a little bit more confusing to learn. So because First has given you some instructions to do command-based, we're going to be doing the time-based robot. The time-based robot is probably the simplest way to get everything together. All the code is going to be in one file, and there's less kind of overhead of creating commands before you can use them. So if we go to timed robot, there's timed robot and timed, we want timed robot, not skeleton. You can click on that. And you should see, so we have template Java timed robot. Now it's asking for a base folder. This folder you can select. This is the folder where all of your stuff is going to be saved. So this would be like if I'll go to my desktop and we can do a new folder, and this can be 2026 FRC code. So all of our different programs are in here. If you save different versions or whatever, you can put them all in this folder. So this is like the folder for all of your software. And then the project name below that has another checkbox. So this is going to create a folder for that project name inside our main code folder. So we can end up with, like I said, if you save the code, you can make backups with different dates or things like that, and all of that can sit inside of our 2026 folder. So this is going to be 2026 KitBot. And I guess you can do spaces. It looks like it let me do a space. And you could do more. You could do a date on that and then change the date as you update stuff. You can put your team number on there, your team name, just to differentiate between maybe other groups that have similar code. And then finally, for team number, you have to put your team number in. Mine is 5599, my fake team number, but you should put your real team number in. And then we have this Enable Desktop Support button. You can check that or not. If you're going to end up doing simulation and stuff, you would need that. Otherwise, it doesn't really matter. And you do have the ability to add it later. So I'll just leave it unchecked this time and click Generate Project. And now it's asking, like, OK, we made the project. Do you want to open it in this window or a new window? This window's fine because we don't have anything open in this window. And then you're going to probably get this pop-up which says, hey, do you trust the authors of the code that is going in this folder? And that's going to allow the computer to run it. So I'm going to check trust the authors of all of these, and then say, yes, I trust the authors. The authors are us. OK. Now, when it first opens, you can see on the bottom it's doing this executing task, Gradle W build, etc. It's doing an initial build of all of the stuff that's here. This could take a little while on your computer. It just depends on how fast your computer is. And so this is going to run through. This first time you open it, it's doing all of this. When you open it again a second or third time, it's going to be a lot faster. So don't worry if this takes a long, long time on the first one. While that's happening, while that's doing its thing, we can start looking at some of the code. So there are a bunch of different files here in all of these different folders. The interesting part is we don't really need to worry about any of it but two things. So one of them is vendor deps. We're going to need to do one thing added here. And the other one is SRC. SRC is source. That's where our actual code files are going to be. So if you go into source, Java, there are two files, main.java and robot.java. And robot.java is the only file we're going to be in, the only file we're going to be editing. That's one of the things that kind of keeps timed robot a little bit simpler. When you do command-based robot, you will typically have multiple files here because it makes more sense to keep stuff organized that way, but then you got to jump back and forth between files. And so this is the template version of what we're working with. And we'll go kind of through the template that's there, and then we'll start adding some of our stuff. So the way that the thing is structured, at the very top, we have these imports. And this is basically importing our ability to use certain types of things. So we have a timed robot. We need to import that. We have a smart dashboard, which we'll look at. That is the thing that pops up when you run the driver station that lets you choose different auto modes. You can also send other information there for debugging. We're going to have to import the ability for us to use like the Spark Max speed controllers. We're going to have to import the ability for us to use our gamepads when we control the robot. Then down here, we have this public class extends timed robot. This is where we start to set things up. So in this case, we are having it more or less create the timed options for our auto mode and sending that to the smart dashboard. We're also going to have to, in here, say like, OK, now that we have the ability to use a Spark Max, the Spark Max that is ID 1 is actually the left drive motor. We're going to have to tell it that specifically. We sort of map everything to where it's going to go here. And then we have kind of this public robot. This is kind of like our initialization step for the entire robot booting up. So we'll do a few things here just to initialize or get things put in the right place. If we need to reverse motors, things like that, we'll end up there. Then, as we come down, we have robot periodic. And you'll notice, like, as we're scrolling through, there's a lot of this green text. Anything that's green text is a comment. And a comment means that it is just notes for the programmer, for the human that's looking at this. The robot or the computer will skip over all of this green text. And to make a green text line, to make a comment, what you do is you do 2 forward slashes. So if you do double slash, then this becomes a comment. And you can see theirs is a little bit different. If you want to do a multi-line one, you can do /*, and then you close it with a */. So everything in between this /* up here and the * becomes a comment as well. OK, so we have robot periodic. This will run over and over, and it is kind of written here. But this will run repeatedly as long as the robot is turned on and connected. Then we have autonomous init. So remember, in our game, there is a 20-second autonomous period at the beginning. That is the pre-programmed portion of the match. After that finishes, then the drivers come in and take over, and they have driver control for the rest of the match. So for this period, when you are autonomously doing stuff, the init function here will run one time at the very start of autonomous mode. So if you needed to like start a timer or do any other initialization stuff, you put it in the init, which is why it's called autonomous init, I assume. Then we have autonomous periodic. This will run over and over again when we're in auto mode. So this is where we'll actually have the like, hey, robot, drive a little bit this way, turn on your launcher, and so on. Then we have teleop init. So teleop stands for teleoperated mode, aka the driver control. So init will run one time at the start of driver control mode. Then we have teleop periodic. That's where we actually put our driver control code. That's what's going to run over and over again. And the code is what's going to end up in between these two curly braces. So we're calling this, or we're creating this function teleop init, and everything in between the curly braces is part of it. And same thing down here for periodic. This would be where we would put it. All right, we have disabled init and disabled periodic. The robot can be in a disabled state. That is an option where none of the outputs are going to be active. There's still sometimes you want to run code there. A lot of times it's like if you're using a camera or something like that, you might want to run it there so you can start looking for things on the field immediately. That's the biggest use, but you might have some other stuff that you want to run constantly. As long as it's not going to an output and controlling motors and stuff like that, you can put it in there. And then finally, we have a few more places. We have test init and test periodic. Those are in test mode. So we talked about that, I think, when we were setting up the control system. But there is an option to choose test mode when you run. And in test mode, you could just put one specific code snippet if you wanted to test that independent of the rest of your code. That way, you can be sure that your code is not, it's not some other part of your code that's causing a bug with your new code. It's just running that new bit of code, so you can guarantee that that's working. And then, of course, we have simulation. And simulation is some of the things that you write can be simulated. So there is a simulator that can run. I think I didn't check the box, so we're not going to use it in this video, of course. But there is a way to simulate the robot's behavior without having a robot. So you can kind of test your program virtually on the computer before the robot's finished being built and you're ready to download the code and test it on the robot. But just be aware that the simulation is not going to be one-to-one with the actual robot. So you can get general things working right, like you can see that the robot drives forward and backwards when you give it the right input on a gamepad. But in terms of the actual speed and movement and how fast things go, that's always going to be a little bit off. So you're going to always have to fine-tune once you get your robot ready. All right, I think we're ready to start some code now. Let's scroll all the way back up to the top. You can see at some point my build was successful in 46 seconds. I talked for much longer than 46 seconds, so we're in pretty good shape there. Let's get a few of our things set up. Let's see if we can get the robot to just move a little bit. And then after the robot moves a little bit, then we're going to go ahead and do our best to use the area we have to set up kind of like at least an area that we can pretend is the field with some dimensions so we can start coding in specific auto modes. All right, first things first at the very top, if we go to that import section, sometimes I like to leave a little space between the ones that are already there and the ones I'm adding, but I think what you'll find too is some of these imports will get added automatically as we use some commands later. So it's nice like that. But we're going to start by doing an import here. And I think the first thing we have to add is we have to add the ability to use the Spark Max speed controllers. And the issue with this is the command is going to be com.revrobotics. And you can see as I'm typing revrobotics, it is not showing up as an autocomplete. And that's because we have not added that library yet to our project. So what you need to do for this step is, I know we turned the robot on, and normally you try to connect to the robot, but make sure you're connected to the internet for this step. And on the left-hand side, you can go down to the WPI Vendor Dependencies tab. If you click on that, it's going to give you a list of all of the different vendor libraries that are kind of out there for us to use. So we already have all of the WPI lib, new commands and stuff like that. But if you scroll down on this list, you will find RevLib. That's what we're looking for. So 2026.0.0, library for all Rev devices, including Spark Flex, Spark Max, and etc. We need the Spark Max. So go ahead and click the install button next to that. And it's going to happen really fast. So at the top now we have RevLib. It actually just has to download one small file in order for this to work. So we have it. It is here, and it is installed. So now, if we come back to this import line that we started, if you do com.revrobotics rev robotics is showing up for us. So the other thing I want to point out is as I'm typing, this autocomplete is like super clutch. If you use this, you're going to have less errors in your code. This language, Java, is set up such that you have to type everything exactly as it's shown. If you miss a capital letter, if you miss a space, if you misspell something, it is not going to work. Obviously, if you misspell it, it's not going to work. But it's case sensitive too. So by hitting Tab, or by clicking here, or by hitting Enter, I think, lots of ways to choose it, it will auto-complete the typing for you. So now that like the top one is highlighted, this com.revrobotics is highlighted, if I hit Tab or click on it, it's going to finish typing out that revrobotics for me. And then it's .star. We're going to replace the star with a spark. And again, you can see spark is showing up, so I'll type that. And then it's going to be a spark max. And I'm going to tab again. So we have com.revrobotics.spark.spark max. A couple things about this line of code. First thing is, you'll note as we were auto-completing, it added these semicolons. So in Java, most lines need a semicolon at the end. The semicolon is like our way of telling the program that that is the end of that command. It added an extra one as we were auto-completing. That's actually kind of OK, because it's the same thing as saying, hey, we have this line of code, and then we have this blank line of code with nothing on it. It's not going to hurt anything, but I'm going to delete it because it is not necessary. The next thing that you'll see is we have this yellow kind of squiggly or yellow carets underneath of this command. And actually, if you hover over it, it kind of tells you what's going on. It says the import com.revrobotics.spark.sparkmax is never used. So this is not an error. This is just saying, hey, you added this thing, and you're not using it anywhere in the program. Are you wasting our time? And the answer is no, because we just didn't get to using it yet. So if you see yellow squigglies, not going to hurt your program. It just might be wasted. But we're going to ignore that for now and move on. Also, I'm going to go back to my file explorer just because it makes me feel better to see that there. It probably doesn't matter. All right, so we now have the ability to use Spark Maxes on our robot. If we go down to this timed robot section, so we have public class robot extends timed robot. And we've got all of this sendable chooser stuff. And you can see it says, hey, this function is run. Oh, that's the next one. All right. So what we need to do here is we need to now create. I'm going to add a few spaces because empty lines don't change anything, right? So if your code looks like this, or if your code looks like this, there's literally no difference as far as the robot is concerned. So when I add extra lines, it's usually just to space out ideas. So this is sort of like this section here is all about our autonomous mode, smart dashboard options. We're going to do more with that later, so I'm not going to explain it too much right now. But what I want to do is now create a new section where I'm going to create like all of our motors or all of our drive motors together. So I'll kind of add a space there. The other thing that you'll notice is these lines of code are tabbed in a little bit. And the reason is because they're inside of this public class robot extends timed robot. We have this open curly brace here, and all the way at the very bottom of our whole program, we have this closed curly brace. So actually, all of this stuff is inside this public class robot extends timed robot. And usually when you're inside one of these functions or one of these classes, what you do is you do a tab, just so it's really easy to look down visually and see, OK, all of these are tabbed over, so they're part of this. Then if you have another thing inside of it, like public robot here, it's tabbed over yet again. So you can see these things are part of this public robot part. And this public robot is tabbed over because it's part of our public class robot extends timed robot. So you don't actually need to do the tabs. If you write the code, if you start the code back here, that's still going to work. It's just going to be a little bit harder to debug stuff. So if you see me tabbing stuff over, that's why I'm doing it. All right, we need to start creating all of our Spark Maxes. And we're going to start with private. Private just means that it is accessible only to this class. In our case, it doesn't matter because all of our code is going inside of here. So whether it's private or public, which is the other option, it's going to work exactly the same. In general, you want things to only be accessible by the stuff that you want it to be accessible by. So making it private is technically a little bit better programming-wise, but the functional difference for you in this simple code is 0. It doesn't matter. We got to type one of them. All right, so we have private. And then we're going to do, in this case, final. And final means the thing that we're doing here, it's really just, it's not going to change. We're going to basically say, hey, left drive motor is plugged in, is CAN ID 1. It's plugged into CAN ID 1. That's going to be the case the entire time we're running the robot. Like that wiring is never going to change. So it's going to be final. And you'll notice too, like as I'm typing these, right, like FIN, final is showing up. So you can hit tab to autocomplete that. You'll also notice that it changes colors. So if I spell final wrong, it's not going to change colors and you will get the red squiggly. That you should keep track of. You'll notice as well, just in case you're looking ahead, robot here just got a red squiggly as we were working on this line of code. Now there's nothing wrong with this line of code, but this line of code up here isn't finished and doesn't have the semicolon at the end. So when this line of code is good with the semicolon, then that error should disappear. But we'll see. We'll keep an eye on that as we go. All right, private final. And next we're going to say, hey, what is the thing that we're defining? And that is going to be a Spark Max. And the next thing we put in is just the name for it. So this is literally whatever you want the name to be. We have 2 left drive motors, 2 right drive motors, and one of them is going to become the leader motor, and the other one is going to become the follower that does whatever the leader motor does. So I'm going to call this one left. Let me move the mouse out of the drive. And this time you have to type the whole thing yourself because we haven't named it yet, so there is nothing to autocomplete. This is going to be my left drive lead. You could call it left drive 1. You could call it LD1. I mean, it doesn't really matter what you type here. Typically, it's better to type a little bit more and have something that's very descriptive. So when you look back at the code later, you'll understand like, OK, this is what I'm looking at. This is the left drive. Not like, hey, what did LD stand for? And then having to do that extra translation. All right. And left drive lead is going to be equal to a new. And it's actually kind of guessing what we want next, which is Spark Max, which is actually correct. So if that pops up for you, you can just hit tab. If not, start typing Spark Max. We want to get, it's going to be a new Spark Max. And this Spark Max has it wants 2 inputs. So you can see after I tabbed Spark Max, it added these parentheses around it. And it has 2 different things entered in here. What's going to happen with some of these, if they want inputs like this, it's going to guess at what should fill them in. So in this case, it guessed that it should have a 0 and a null. The other thing is, if you look carefully, you see how there's a 0 here, and next to it, it says device ID. On your computer, if it's doing this, you'll notice if you use the arrow keys to jump over one space, it jumps over the entire device ID in one go. That's because the device ID is a label. I did not type it. I will not type it. If I delete the 0, it all goes away. If I put the 0 back, it will at some point pop that label back up. So that's just trying to describe what it is that we're putting inside here. So just know if you ever see that gray text on the screen, don't type that. It's a label. You can ignore it. I think there is an option to turn it off. And so if yours is not popping it up, don't worry about it as long as you have the number. Now, left drive was, and we could look back through, but I remember it was in CAN ID 1. So for device ID in here, I'm not going to leave it at 0. I'm going to switch it to 1. And then it's going to add the device ID colon. So we are in port 1 for that. The second part, if we hover over it, sometimes it will tell us. Well, now I can't get it to do it again. All right. This one is asking for, there we go, type. So device ID is the CAN ID of the device. Type is what type of motor are we plugging in. So in this case, it's either going to be brushed or brushless. And we are using a brushed motor. So for our type, we're going to do motor type. And I'll tab to autocomplete, dot. And then we have 2 choices after the dot. We can do K brushed or K brushless. Our sim motors are brushed motors. In fact, all the motors we're using are brushed motors. So go ahead and choose K brushed. All right, and we still have one tiny little squiggly here on the screen. And that is because we need a semicolon at the end of our line of code. And you'll notice the robot is no longer red squigglied after we completed this code correctly. All right, we do have the yellow squiggly for left drive lead. It says, hey, you created this motor that we're not using yet. But if you scroll up, by the way, Spark Max no longer has the squiggly on it because we're using it now. You'll also notice it should have added this import com.revrobotics.spark.spark low-level.motor type line of code, this new import for us. Because when we did motor type.kbrushed, Turns out we needed this import, and it added it for us. I like adding the Spark Max so that we can autocomplete this line of code as we're going through. But now it's sort of like we'll add things if we're using them and we didn't explicitly add them. So it should fix that for you. But if it didn't, you can also add this line of code. All right, so that was one motor. We're going to do the same thing 3 more times for our other 3 drive motors. So it's going to be, again, private, final, Spark Max. And this is going to be left drive. And you can call it whatever you want, again, but this is my follower motor, so I'm going to call it follow. And that's going to be equal to. Also, these spaces sometimes are needed, sometimes aren't. In this case, you don't necessarily need a space here, but I think it's cleaner to see what's going on with the space. So I'm going to add spaces. This is a new Spark Max. And our second left drive motor was import 2. And for this null, we're going to get rid of that. It is going to be a motor type, and it is going to be K brushed. And don't forget a semicolon at the end of the line. All right, looks good. That's 2 of our motors. Of course, you can copy and paste if you prefer for these lines of code because they are so similar. We're going to do private, final, Spark Max. This is going to be right drive lead. And again, that's the name, so that's the one you can call it differently if you want. It's going to be a new Spark Max. This is import 3. And it is a motor type .k brushed. With a semicolon. And yeah, same thing. One more time, private, final, Spark Max. This is right drive follow equals new, Spark Max. This is going to be import 4. And it's still motor type .k brushed. With a semicolon. All right, so now we have basically added all 4 of our motors into kind of our hardware map here. We know where they're plugged in. We can now try to use those motors. Let's just do a random quick program to make sure everything is working. A lot of times the first download is the hardest part in order to get stuff to work. So we're going to do a quick program where we just turn one motor on, and the robot should move a little bit. And that's what we're going to test here. All right, so let's go down to, let's do autonomous periodic. Find autonomous periodic. So it should be on or around line 71. Remember, I did some extra enters. If you did extra enters, you might be a couple lines off. That's fine. And inside here, there's some things going on. So first we have this switch, and it's saying, look at the value of M auto selected. And that is that whole smart dashboard where we pick stuff. And then underneath that, it's saying basically if the value of this is K custom auto, we run the code inside here, in between the colon and the break. If not, if you choose default auto, or if it's something else, if it's not either of these 2 things, it will always run what's in between the default and the break. So let's go into the default case for now, so we can just make sure our stuff is running. And really, all we want to do is turn our motor on. And in fact, let's just turn it on and not worry about turning it off. We're going to that motor is going to turn on. It's going to run forever. What we actually can do is probably prop the robot on something so the wheel's off the ground. So when it starts driving, we don't have a problem where it crashes into stuff. OK, so this line of code is going to look like this. Anytime you want to control something, you start with the name of the thing you were trying to control. So in this case, let's just do left drive lead. We're going to control left drive lead. And then you follow it with a dot. And when you do the dot, these are all of the commands that we can do that basically involve a Spark Max or one of our motors. And in our case, we want to do .set. Now, there's a couple of types of set that we can use. We have set, and this is basically just going to be a speed. So in this case, we could send it a number between -1 and 1. 1 would be basically however much voltage the battery has, send all of it to the motor. -1 would be flip the polarity, send all of it backwards to the motor, so the motor would run in reverse. 0 would be turn the motor off, and then we can use any decimal in between. So if we want to send half of the battery's power to the motor or voltage to the motor, we can do 0.5. If we want to do 3/4, we can do 0.75, and so on. There's another option that we're going to try to use for a lot of the things that we're doing here, and that is set voltage. So we also have this set voltage. Now, set voltage we have some more setup stuff that I think we might have to do in order for this to really work out well. But set voltage, we're going to start using later. Not for this step, but later. Set voltage basically says, OK, well, we can read in what the battery voltage is. We can then use that to know what % of that battery voltage should get sent to the motor to give it a specific amount of voltage. So a battery will start when it's fully charged at like 13-ish volts. And then it'll quickly kind of drop down into the upper 12s. But as you're driving around, the battery voltage is going to decrease over time. And so for some of the things like the shooter wheel later on, we want that shooter wheel to spin at a relatively consistent speed. If we basically say run it at 80% of the motor's of the battery's voltage, or at battery's power, if you say 80%, right? At the start of the match when the battery's charged, that 80% is going to be more than at the end of the match when the battery's dying or dead. So by using set voltage, it will make an adjustment. So at the beginning of the match, we won't be able to go quite as much power. We'll have to go down a little bit to, like, say, if you do like 10 volts or 12 volts. But at the end of the match, if we still have 10 or 12 volts available, we can still send the same amount of power to the motor, which means that it should spin the same speed, which means our shot should be the same, distance. That can help also with driving around in autonomous mode by sending voltage to the motors instead of just this open-ended full power. We can sort of maybe drive a little bit more accurately. Now that's less important because every time you put the robot on the field for autonomous mode, you should be starting with a fully charged battery. So it's going to be roughly the same for the first bit of the match. All right, so in our case, let's do just a set command first to get things tested. So I'm going to choose set. And the speed, again, we can do any number between -1 and 1. I'm going to choose a relatively small number. Let's do 0.35. And it doesn't really matter what number you pick. You could do 0.5, you could do faster, you could do slower. But I kind of don't want to go all out the first time I run it. So I'll choose something that's like 35%, seems good. All right, so when we run our robot now and we run this auto mode, the default auto mode, that motor is going to turn on. It's never going to turn off. So let's go ahead and do a couple of things. Well, first thing is we can start downloading this to the robot because it won't run until we actually use our driver station to be able to control stuff. So if you click on the WPI Live command palette, we're going to type deploy. You're looking for deploy robot code. And click on that. So this is going to build our program, and then it is going to actually send it and download it to the robot. Now, mine's not going to work. I'm going to explain why as soon as it errors out. But deploy, I was going to also say deploy will also save the program, I believe, when you run it. So it never hurts to do file save, just to make sure you don't lose anything. But every time you deploy, I think it does a save too. So I got a build failed. And if you get a build failed, one of the things you want to do is kind of scroll up. And if you see anywhere where it says like discover RoboRio failed missing target, if you see things like missing target, are you connected to the robot? Then your error is going to not be a code error. It's going to be that you did not connect to the robot's wireless network. So that is number one for troubleshooting this. If you try to download the robot, if you try to control the robot and it can't find the robot, first step is always going to be go to your wireless networks and make sure you are connected to your robot. I am not. Remember we had to connect to the internet to do that, add in that vendor library? We need to now be connected to the robot in order for this to work. So find your FRC team number and connect to that. And you could, if you wanted to go really far, you could forget every other wireless network. So if your school's wireless network is available to you, if you forget that that exists, then it will always reconnect to your robot. Just might be annoying when you do have to switch over to the internet to look something up or download a vendor library. All right, so this will take a second. It's going to run, and it's going to do a, remember, it's going to say, like, connected, but no internet is available, and that's what we want to see. And meanwhile, while that's going, I am going to grab some safety glasses here. Well, these ones look really scratched up. Let me grab my other pair. All right. When you're running the robot, there is some safety stuff to keep in mind. Remember that you should probably be wearing safety glasses. The robot is going to move. There are some dangerous parts of the robot, especially pinch points like the gears. Obviously, the robot can crash into somebody and knock them over as well. So anytime you're ready to start running the robot, make sure your whole team knows before you enable it and let it move. Make sure that everybody's kind of paying attention at that point. Now we have one more thing we need to kind of figure out here, and that is our robot. In theory, the left motor is going to move, but we want kind of this robot to not actually be moving. So I want to set it up on top of something in order to stop that from happening. And I'm wondering if we can use the crate to do that. So let's see if we can kind of get that propped up on here. All right. So when you do something like this, make sure it's on, make sure it's stable and not going to, tip off when things start moving. That feels pretty secure. And the other thing is make sure the things that are going to move, in this case the wheels, are not hitting the thing you're supporting it with, because if those are hitting, obviously it's going to drive away. So I can spin both sides wheels freely right now. They're not hitting anything. Robot's up in the air, so this is kind of like a bench test. And I don't have to worry now about the robot taking off and driving and crashing into stuff. OK, I think we're ready now to test this code. We are connected, right? No internet, secured, showing up. That's what we want to see. Next thing we have to do is deploy the code again. So we're going to do deploy robot code. And there is a specific window that's going to pop up here, the real log window that will let you know when this is done. So in this case, I'll wait for it before we move on. All right, see this window pops up, this real log here. When that pops up, it is done uploading or deploying the code. You can close this window right away. We probably won't use it. And then we need to run the driver station. Now, you could have run the driver station at any point during this and left it running. Say yes. That's not going to hurt anything, so you can do all of the coding with the driver station open. I probably will not close it again today. But the driver station, again, is what lets us control the robot. So when your driver station runs, you should be green light on communications. And now we should have a green light on robot code. When we did this sort of test in the setup video, it was a red light for code because we hadn't deployed code yet, but now we have deployed code. Also, the smart dashboard, it is saying it will not work with the 2027 control system. That's not really a problem for us because it's 2026. And you can see, remember I said we had my auto and default auto as our two choices, and we put our code in default auto. So this list is going to get bigger as we add more auto modes, but go ahead and click default auto for starters. And then down here, we can choose whether we want to run teleoperated mode, autonomous mode, practice, or test. In this case, we want autonomous mode. And the last thing is, I always like to think before we run the robot, before I click this enable button down here, what do I expect to happen, right? So we did code that turns on just the left drive motor. So in this case, the left drive motor should be this side. So this side of the robot should spin such that it would be going forwards. And I think forwards, in our case, is towards our intake roller. So we want to see those wheels going in kind of this direction, right? So we want to see them going, that would drive the robot forward, but on this side. All right. And then the last thing is prepare yourself for what to do if something bad happens. So on the driver station, obviously there is a disable button that you can click immediately. So you have the enable button, you have the disable button to click to turn it off. The enter button on the keyboard, I believe, and you should test this, is also the disable shortcut. So you can hit the enter button to disable it. And then finally, spacebar is e-stop, I think just because it's big and easy to hit. Now, if you do the e-stop, I believe you have to reboot the robot and the driver station software. At least the robot has to be rebooted before you can ever turn it back on. So that's like a full safety, shut it down, I'm hitting whatever I can hit, and then we'll just have to reset everything to get back to it. OK, so I'm going to click enable and see what happens. I'm ready to hit enter or click disable if it looks like things are going amiss. OK, so here we go. Everything looks fine, so I feel like I can step away from my computer to take a look. And I can see that these wheels are going, the tops are moving forward. So these wheels are going in a way that would make the robot drive forward. All right, let's try the enter button. Enter worked, disabled, perfect. OK, so that worked. If you got this far, if your robot was able to get connected, download code, and have the motor running, that is the hardest part, I think. Okay, let's jump back into our code. And let's just do another quick test here. Like, what if we needed to control the right motor to make it spin? Because I think we're going to learn something here about the right motor. So in our code, find where you did left drive lead.set. Hit enter. Let's get the next line of code. And we're going to do right drive lead.set. Okay, and let's just do the same speed. So I'm going to do 0.35. So it's going to be 0.35 and 0.35. Now again, our hope here is that the right side wheels are going to rotate forward and the left side wheels are going to rotate forward. So we kind of got both of them going in the same way. Let's click the icon, the DPPI Live command palette icon, do deploy robot code. And then as soon as this kind of pops up and we get the real log, then we can switch over to our driver station and give it a test. Okay, looks good. Go to the driver station. We're still on default auto, autonomous, and I'm going to enable. Okay. So it looks like both of my motors are going forward at the same time, which is not what I expected, but that is kind of cool. So in this case, now we can test. So first of all, if your motors are backwards, one of the things you can do is in the software, you could switch the 0.35 to negative 0.35. We'll also look at how we can reverse the direction of a motor in code when we do the setup. But let's go ahead and put this on the ground and verify that it drives forward. So I'm going to make sure that we are disabled. We are in disabled mode. Cool. And then, I think it's safe enough to tip this back down when the robot's in disabled mode. But it is OK if you want to be super extra safe to turn the robot off. Of course, then you will have to wait for it to reboot before you can control it again. All right, let's get that crate out of the way here. So we expect the robot to drive this direction. So I'm going to pull it kind of back so we have a little bit of space here. But I'm not going to go all the way to the wall. So I have some space back here to disable it in case it does what I didn't expect. All right, now let's see if it actually drives forward here. OK, so autonomous mode. And then we're going to enable. Here we go. 3, 2, 1. And then I'm going to disable it quickly because it took off. So that did drive forward. That's what we wanted to see. Drag it back here. Can do it one more time, maybe going sideways instead. So we'll enable, and then we'll kind of disable it quickly. OK, so right now our robot is capable of driving forward. We're controlling the left side and the right side of our drivetrain, which is great. All right, so right now we have to control both left and right motors separately, and then we would actually have to control left follow and right follow separately as well. So if we continued to code like this, every time we wanted to move in our program, we would need 4 lines of code in order to control stuff. That's it. Left drive.set, left drive lead.set, left drive follow.set, right drive lead.set, right drive follow.set. We can make this work a little bit better and make it so that our driver control program is a little bit simpler for us by combining all of the drive motors into a drivetrain object. Then we can tell it specifically just make the left side do this, make the right side do that, or we can tell it make the whole robot go forward or backwards, and it will do the conversions and math for us. So down here, because we tested this and this worked, you can either delete these 2 lines of code or comment them out for later. I guess I'll just comment mine out. So double slashes, we'll turn them green. And then let's go all the way back up to the top. Also, I do want to say, it's really weird that these both forward worked. I would really expect one side to be backwards because, again, we have motors that are facing one way, and when you bring them over to the other side of the robot, they're now facing backwards. So clockwise on this side and clockwise on this side should make the robot go in opposite directions. So we might still run into it. We might find out that one side is backwards, and it was just kind of like figuring stuff out here. It is also possible, and we can go and check the robot as well when we get to this point, if we got any of our red and black wires going to the motors flipped over, that would change the polarity of the motor, and that would have it go differently. And the other thing is sometimes the motors come from the factory just on accident, and they're wired backwards. So I would have expected it to turn. If yours turned, know that that's probably correct. And we'll investigate more kind of as we move on to the next part of our program. All right, so once again, let's go all the way back up to the top where we have our imports. I'll leave another little space here, and we're going to do another import. We're going to import. And this time, it's going to be from this edu.wpi.first, et cetera. So we're going to do edu.wpi.first.wpi-libj dot, and this is going to be drive, wpi-libj dot, yep, drive dot, and this is going to be differential drive. So differential drive just refers to any drivetrain that is able to turn by running differential power to the two sides. So kind of like a tank or a skid steer, in order to turn this robot, we can't like do steering wheels. It's not like a car. We have to run one side of the wheels forward and one side backwards, and that will get it to turn in place. That's usually like called a tank drive, or in this case, a differential drive. So now that we've created our differential drive, we have to set it up. We have the ability to use differential drives. It's still yellow squiggly. We are not using it yet. It also, you'll note that oh no, we're good. All right. It added this like spark line here, and that's not being used. Probably that could be deleted. I'm just going to leave it. So if it added that for you, don't worry about it. If it didn't add it for you, also don't worry about it. All right, so down here where we have these, where we set up our 4 motors. The next thing we're going to do is set up our drivetrain. So we're going to do private, once again, final once again. Okay, and this is going to be a differential drive. That's what we just gave ourselves the ability to use. Space, and then now we get to name the differential drive, what we're calling our drive. Now, I think you could just call it drive, but it seems like too common a word, and I'm afraid sometimes that might be a special keyword for something else. I'm just going to call this one my drive. And that is going to be equal to a new differential drive. Okay, then inside here, it's asking for what is the left motor that I should control and what is the right motor that I should control. Well, the left motor is going to be left drive lead, our leader motor. And then the right motor, the right drive motor, is going to be right drive lead. Okay, and make sure there's a semicolon if it did not auto add that for you. I think depending on where you auto complete, sometimes it adds it, sometimes it doesn't. So now we have this drivetrain object, this my drive that we can use that is mapped to our left drive lead and our right drive lead motors. Okay, but now that we've set it up that way, we also have to tell it to have the follower motor follow the leader motor, right? So this is, unfortunately, this part is going to be a little weird, but let's go down to public robot. So this function is run when the robot is first started up and should be used for initialization code. I'm going to go below this smart mchooser smart dashboard lines. And we're going to have to do a config. We have to create a config, and then send it to all of our motors. So we do that by starting with a SparkMax config. And that might have added, oh, not yet. All right, sometimes that will add another import, but we're not quite there yet. All right, we can now name the config whatever we want. This is our drive config, so I'm going to call it drive config. You could just call it config. You could call it just a letter, doesn't matter. Just a name to keep stuff straight. And that is going to be equal to a new SparkMax config. And we don't have to put anything inside the parentheses for this one yet. Okay, then we hit enter. All right, and now what we do is drive config. the thing we just created, we're going to set values for this configuration. So we're going to do dot. And the first thing we're going to do is voltage compensation. And we're going to say 12 volts is our nominal voltage. So if you remember when I said you could use the set command or the set voltage command, this we have to set up in order for it to start using, to know kind of what the nominal voltage is and to be able to make those adjustments. So we do voltage for 12. Then we're going to do another line. We have to set one more thing for this config, drive config dot. And that is going to be our smart current limit. So the Spark Maxes can keep track of how much current kind of they're pulling, how much current they're sending to the motor. We can put a limit here so that if something goes wrong, instead of just like continuing to try to do its thing and pulling more and more and more and more current and burning something out, we can have a little thing here that could trip out, a little like software breaker that will help protect things. So in this case, we'll do 60. That should be plenty. If you find that your robot is trying to drive around and it keeps kind of cutting out on you, you could raise this a little bit, but that's probably a sign that you should start looking mechanically at the robot and see if anything is binding up. All right, so now we made our config. This is the same config that we want to send essentially to all of the motors, except we need to also do the following part. So the last line that we're going to do is drive config dot, and we're going to choose follow. We're going to say follow. Okay, so now when we write this config, any motors that we write this config to will follow the motor that we put in here. So the motor that we want to follow is left drive lead, right? So the follower should follow the lead. Okay, so now all of these things have been written to our config file. They're all saved in the config file. Now we actually send that config file to our first motor. So left drive follow, right? Because the one that we want to follow the left drive lead is the left drive follow motor. And we're going to do dot configure. And again, it guessed what we wanted to fill in these areas, and mine guessed drive config, which is right. So the first thing we put in here is what is the configuration file that we want to send. Then it's asking what's the reset mode and what's the persist mode. And we are going to change both of those from null. So instead of null, we're going to do reset mode. Whoa, I clicked somewhere. We're going to do reset mode dot. Okay, and we want to k-reset safe parameters. K-reset safe parameters. And then for persist mode, we're going to do persist mode dot. And again, make sure you do persist parameters, not no persist parameters. Same thing with the earlier one, reset safe parameters, not no reset safe parameters. They look similar. Okay? And then we'll throw our semicolon on there. So now our left drive motor, our left drive follow motor is configured. It got the voltage compensation, it got the current limit, and it knows to follow left drive lead. Now we're going to do the same thing for the right drive motor, except now we don't want to follow left drive lead anymore. So we have to change our drive config. So we're going to do drive config again dot follow, but this time the right follower should follow right drive lead. And that's the only change we have to make, right? The right follower should have the same voltage compensation, should have the same smart current limit. The only difference is instead of following the left drive leader, we need to follow the right drive lead motor. So then we can do this line of code again. And again, you could probably copy and paste this. That would probably save you some time. But we're going to do right drive follow dot configure. And drive config is correct, right? Our first null is going to become reset mode dot k reset parameters. And then our persist mode is going to be persist mode dot k persist parameters. So now our two follower motors are set. We've done configs for both of them. We now have to do the configuration for our lead motors. So we have to basically tell it, OK, no longer should you be following. So drive config. And we'll do .disable follower mode. That turns off follower mode. So no longer is there a motor that this motor is supposed to follow. And then we can write our write drive lead motor .configure. Going to be drive config, and everything else is the same. So reset mode .kReset safe parameters. And then our persist mode is persist mode .k reset persist parameter, or k persist parameter. Sorry, no reset on that one. All right, now, if you needed to invert stuff, well, first of all, if you needed to invert the right motor, you would have to do this line of code before the right motor. If you need to invert the left motor, I'll do the example like the left motor needed to be inverted. That's what I think was supposed to happen. We'll learn more later. What you can do is drive config dot inverted. And now inside of here, if you put true, it inverts the motor. If you put false, it does not invert the motor. So we could actually do that line of code again up here as well. So if you go above the right drive lead, you can do drive config dot inverted. And I'm going to put false, because in theory, we don't need to invert there. So if it's false, obviously, you don't have to type it at all. But now this line of code is here. So if we find that our robot is acting funny and we got to flip something, we know to come change this false to a true. And then same thing down here. If your left side was flipped, if your left motors went backwards when you did those earlier tests, then you should flip this to true. Otherwise, you can make this one false. And same thing, if your right motor was going backwards earlier, make that one true. If not, leave it false. OK, then we've already turned off follower mode. So it really is no change. We're ready to write our left drive lead. Configure. Drive config is correct. Reset mode. .k reset safe parameters. And the other one is persist mode. .k persist parameters. Get your semicolon. All right, now after all of that, we should be able to use our drivetrain object. It should use all 4 of our motors instead of just 2 when we drive around. So I think we're ready now to go back to autonomous mode. Scroll all the way down to our autonomous mode. So right where we had those lines commented out, let's do a brand new one. And this is going to be our test for the entire drivetrain. So again, we start with the name of the thing we want to control, which was we called the drivetrain object that we created myDrive. And we're going to do a dot. And we have some options here. We have arcade drive, and tank drive is the other option. So let's do tank drive first, because that will mimic kind of how we were doing stuff before. So if you do myDrive.tankDrive, and now it tried to fill 2 things in. It put kdefault period in both spots, and that's a really bad guess. That is not even close to what we want here. What we want is what value do we want to send to the left motor, and what value do we want to send to the right motor. And in this case, I mean, we can just do our 0.35 to the left motor, and for the right motor, also 0.35. So once again, we have done the exact same code, which should have the robot drive forward with both motors at 35% speed. OK, let's go ahead and start this deploying. OK, and while that's deploying, I will go ahead and let's aim the robot. I think it seemed easier to follow when I had it going sideways here. So I'll get it pointing away from me into where we have some open space. And our real log is finished. OK, so I'll close that. I'll open up my driver station window. Make sure you're on default auto, because that's what's running. And once again, when we enable it, we expect it to drive forward. There is a chance that it spins if you didn't get your inverts correct. So be ready to disable if it looks like it's going to crash into something. Otherwise, I'm going to enable it for just like a second so it drives forward, and then disable. And here we go. 3, 2, 1, enable. Ah, all right. All right. Couple things. Let's go back to the code really quick. My robot was trying to turn. And actually, if we look at the robot, which it turned this way, right? So that means that the right side was going forward and the left side was going backwards. That's really weird. I'm not sure why it is now doing what I expected it to do, but it didn't before. But anyway, doesn't matter. Let's go into our code. So one thing that we're seeing is turning needs maybe a higher power than driving straight. So that's something that we need to think about. But let's go all the way up to our config area. The left motor needs to get flipped. So for whatever reason, it didn't before, but it does now. So drive config.inverted, the one just above left drive lead, where we write to left drive lead, let's change that false to a true. I was saying the word false, so I typed false. All right. So now, and remember, the inverted colon, that's a label. I didn't type that in. I just typed true. So now right side is not inverted. That looked correct. Left side should become inverted. That looks good. And then our robot didn't turn really well at 0.35 speed, at 35% of the 12 volts going to the left and right side. But now we should drive forward, so I don't want to change it to tune that turn value in. We'll do that later when we get to some turning. All right, let's get this deploying. I got to remember to deploy and then talk. All right, so that's deploying. Robot is fine. I just relined it up anyway, so we're set with that. And this time when we run it, we should hopefully see it driving straight forward. And again, if yours is rotating, if it's rotating to the left, it means your left motor is going backwards. If it's rotating to the right, it means your right motor is going backwards. If it's driving backwards, it means both of them need to get inverted. And if it's driving forward, then you didn't have to flip anything. You were good to go. All right, let's give this a try. So I'm on default autonomous. We're going to enable, and we should see it hopefully drive forward this time. That looks good. OK, the other thing that you will have noticed here is it was a little slower, I think, than when we did the 0.35 power before. That is, again, because our battery is actually at 12.6 volts. You can see it kind of here at 12.59, 12.6. And we instead said, hey, let's only work with 0 to 12 volts. That's our nominal voltage. OK, I think we can do one more test to set up our code before we need to stop and try to make a fake goal and mark out some areas on the carpet. So the last thing that we want to do is we want to be able to figure out how we can make something happen for only a certain amount of time before we want it to stop. So obviously, when we're doing any of our steps in auto mode, we're going to want to like spool up the shooter for a little bit. Then we're going to want to launch balls for a little bit. Then we're going to want to drive for a little bit. Maybe we drive for a little bit first, but we don't want to drive forever. We need some way to turn it off using time. So let's set that up, and then we'll be ready to do our actual auto mode once we have our field marked out here. OK, so in the code, scroll all the way up to the top where our imports are, and you can see, actually, we have some more imports here. Persist mode, resist mode it added, Spark Max config it added at some point. That's all great. Again, I have this one that I think it added on accident. That's no problem. Probably that's because I auto-completed Spark instead of Spark Max once. And so it added this because it thought I was talking about a regular Spark. So again, this line of code, if you have it, you don't need it. It's fine to leave it there. It's fine to delete it. It's not going to hurt you anyway. All right, I'm going to go below all the imports we've done and do a brand new import. This one is going to be that's going to be edu.wpi.first.wpi-libj. And this time we are going to add a timer. So the easiest way for us to control things on this robot, we don't have sensors that tell us how often the wheel has spun, how many times the wheel has rotated. The only kind of sensor that we have is a stopwatch. We can use a timer and say, let's move for this much time. And we can be decently accurate with that. So we'll start out with our timer here. Now, inside of this area where we're creating our actual objects that we can use, we have to create one for the timer. So I'm going to do private final. We're making a timer. So choose timer. Next thing is you name the timer. And we're going to have a timer that we use for our launcher in autonomous mode, that we use for our launcher in teleoperated mode. And we need our timer for autonomous mode. So I'm going to create maybe 2 timers this time. You could probably reuse the same one. But I'm going to call this one auto timer. This is our timer for auto mode. And that's going to equal a new timer. And get a semicolon at the end of that line. We don't have to put anything inside of this parentheses at all. All right. Now, in robot, I don't think we have to do anything this time in robot. What we do have to do is we have to start our timer at some point. And I think the best place to start the timer is autonomous init. If you find autonomous init somewhere around 88, or 93 is the line I'm going to end up being on. But make sure you're inside the 2 curly braces for autonomous init. Remember, this runs 1 time at the very start of auto mode. So if you were going to have a stopwatch that you were going to use to say drive for 1 second at the start of auto mode, you would want that stopwatch to start right at the beginning of auto mode. We can't put it inside the autonomous periodic because that runs over and over again. So if you say, hey, start the stopwatch here, it'll just keep starting over and over again. So instead, init happens once right at the very beginning, so that's perfect. We can do auto timer dot, and the command is start. So this will basically click the go button on the stopwatch. Now it's at 0 seconds. It's counting up. And we can use that then in our code down here to know when it's time to stop driving forward. I think I'm going to, just for fun, so it goes a little faster, I'm going to increase my speed up to 0.5. See how that goes. And then what we need to do is get the line above that drive that we did. And what we need to do is we need to now make basically a decision. So we're going to use an if statement. An if statement basically says, OK, if whatever is inside these parentheses is a true statement, run the code. That's part of this if. If not, skip that code. Don't run it. So what we're looking at is if auto timer, we want to look at that timer value. Now, it turns out to look at the timer value, you have to do .get. So auto timer .get is going to tell us the value on the stopwatch. If the stopwatch is, let's say we want to drive forward for 1 second. So if the stopwatch is less than 1.0, you can just do 1, but you know you can use decimals here. Then we're going to do open curly brace, and it adds the close. I'm going to delete the close curly brace, tab this over, and then I'm going to hit enter and put the close curly brace below our my drive line. So now what this is saying is if autotimer.get, if our stopwatch is less than 1 second, so we run this code over and over again, and as long as the stopwatch is less than 1 second, drive forward at 0.5. So when we start, it's at 0. That's good. It's going to drive this. At 0.1, it's still driving. At 0.2, it's still driving, and so on until we get to 1 second. When we get to 1 second, it's no longer going to be driving forward, but we have another problem. We have to now explicitly turn the motors off. So sometimes they continue doing whatever you commanded them last until you give them a new command. So the next part of this statement is going to be else. And do an open and close curly brace. Go ahead and hit enter. Now, what this says is if we're less than 1 second, obviously we run this code. If not, otherwise, else we run this code. And this code needs to be kind of the same, my drive, .tank drive. And the difference is if we want to stop moving, we have to send it 0 and 0. That's basically turn off. No power to either side. So now this code should drive forward for 1 second and then stop. Let's deploy the code. And then we're going to, while this code is deploying, let's get the robot dragged back over to the table here. So we've got room in the direction we want to go. Okay, that looks good. Real log popped up. We know we're done downloading or deploying. And so now we're in autonomous mode. Still default auto looks good. All right. So we're going to enable it. This time, I'm not going to disable it. I'm not going to click the disable button unless it doesn't stop when I expect it to. And I expect it to go forward for about 1 second. So if it keeps going forward after about 1 second, then I'm going to get scared and I'm going to hit the disable button. Now, on the driver station, by the way, you can see elapsed time. So you don't have to rely on your ability to count 1 second. If that hits 2, 3, 4 and it hasn't stopped, you should disable it. All right, here we go. I'm going to enable in 3, 2, 1, go. And it stopped right at 1 second. All right. We can set it up too, and just so you know, you can always disable. And we can, you know what? I don't know if we can enable again. Let's learn. I'm going to try to enable it again. And it did not move this time at all. So if your robot does that, that is normal the way we coded it. We have to kind of make one change in the code to fix that. And that is where we do autotimer.start. Turns out if you run start a second time, it's not starting again. But we want to reset our timer as well. So if you're going to run your auto mode a second time or a third time, which is very common, like you might be out there, you run it once and you'd be like, did that work? Was it a little off? Let's just run it again to get more data. Then you want to just run it again. You don't want to have to like restart your entire robot before you can do that. So in this autonomous init area, underneath autotimer.start, we can also do autotimer.reset. And that basically is like clear it, go back to 0. So now when we run it a second time, you'll be able to, it will be able to actually do it. It will reset the stopwatch and we'll have another less than 1 second situation. So we'll deploy that. We'll try it really quickly. All right, looks good. So here we go, enable. 3, 2, 1. OK, that was the 1 second driving forward. Let's drag it back a little bit. Disable. Probably should have disabled before I dragged it back. And now when I enable the second time, it should work again. Perfect. All right, so now we can test our auto modes over and over again. I think the groundwork is now laid. So the next step, let me grab some things so we can simulate a goal. And I'll also get some tape and a tape measure so we can start laying out where the field elements should be. All right, so I pulled up in the game manual, and there is also a field dimension drawings on my computer, just so we can kind of get a sense of the size of things. So first of all, this is the hub where we're trying to shoot and score the balls. You can do this in autonomous mode. They're worth a point apiece. That's probably the best thing to do. Remember, I think you can start with 8 balls preloaded in the robot. So you might as well, line up, shoot those 8 balls in, and go do something else. Save some time there. But it looks like the hub is 72 inches tall and 41.7 inches kind of from side to side. It's this hexagon that's 47 inches across. So that's a little hard for us to replicate. I think if you get if you get a box that's kind of this size, if you could get like a 41.7 by, so that would be here. Yeah, if it was like a 41.7 by 40.17 square box or a 40-inch by 40-inch square box, that would be like a decent approximation of this. You could cut cardboard and kind of make something that's roughly the same size. So what I did was I just grabbed some stuff. I mean, we have these crates that obviously the KitBot pieces came in. Unfortunately, they're only, to the opening, like 24 inches wide. So it's almost, right, like we said it was about 41 from side to side. So it would be like this much longer. It is significantly bigger than this crate. Maybe if you took one crate and put another one side by side, that could work. So I'm just going to know when we're doing testing here. Obviously, this isn't a full field. It's not built that way. But the height should be pretty close. So I'm up to, all right, I'm 71 3/4 to the edge of that. So I'm a little short. And I just took some of the extra wood we used to make the electrical board out of, or bumpers. I have a second crate here, box of sockets. Whatever you have that you can stack up to kind of get that height, the better. And then, we'll test this. This is probably going to get knocked around for our testing. If you're doing a lot of practicing, maybe you want to add some tape so this doesn't move. Or, again, if these two crates were nested in each other, that probably would be better as well. So whatever you can do to find something at about that height, right? And so we're looking for 72 inches up, 6 feet, as close as you can get to that. And then also know, too, that depth-wise, and you'll have to trust me on this, at the top, it's only about 16 inches depth-wise. And we know, again, it's going to be closer to 40. So this is like 40 would be, out to like here on it. So that's another almost 8 or 9 inches to the front and all the way to the wall. So basically, when I'm launching stuff here, if it's a little bit short, that's kind of still, well, what we could say is, if it's in, it's in. If it goes all the way behind it and falls anywhere between it and the wall, that's still in. And in fact, if it hits the wall, probably in kind of any of this area up until maybe the start of our logo here or something, that probably also falls in. So we're not going to be able to really tune our shooter expertly, but we will know if it's getting high enough to get over the front edge of the goal. And I think that's the biggest thing we're looking for. All right, so if this is our goal that we have set up, and again, like a cardboard box on top of a stack of stuff, a table and whatever, or a stool and some more things, whatever you got to do to get something kind of in the right place works. Obviously, if you buy some wood, you can build something a little bit better, and there is some instructions for a homemade version of this hub, but it is very big, which makes it hard to kind of build and have set up. All right, let's go back and check the layout now for the field. So there was this other file here that you can get. If you go to the season stuff, there is playing field, a playing field section, official assets, and then there is the field dimension drawings, which is what I have opened up here. And so this one got a lot of numbers on it, but we can kind of start to estimate stuff. So we can see we have this big goal here in the middle. That's the hub that we're going to be scoring at. There's a line running across right here. I think if I go to the top one, the color version here, like this red tape line or this blue tape line, that runs all the way across just in front of the bump, that is the robot's starting line. So our robot has to start a match with its bumpers over that tape line, but not touching the bump, which means you can be just the edge of your robot on that tape line, or you could be all the way over in this edge, but that doesn't make sense. If we think about what makes the most sense for us, our robot, if it starts right flat on this edge, either it can make that shot, or we'll have to back up a little bit, and then it can make the shot. Like, we know that's a good place for the robot to shoot from. So it's having an auto mode that starts here and does something, and then we've got kind of two options afterwards. We'll look at the blue side for this. One option is drive all the way over to the human player, where they can actually dump these in, and the open top of this robot will catch some, or probably not all, but it will catch some of these balls. Then you could maybe even try driving back and shooting a second time. The other option is to shoot and then maybe drive over to this small section of balls on the field here. And if you drive through there, maybe you can pick up a few. It might not get, again, all of them. And then drive back and try to shoot those. The last option is, well, if you add to the KitBot and you have the ability to hang, there is a chance that hanging on this is worth it. One of your partners might be doing that as well, though. And that is a reason why we might not be able to start directly in front of the hub. So that's another possible option that we're going to need to have. So if somebody wants to start right in front of the hub so they can go and hang to get those bonus points, then we might have to start off to the side. And then if we're off to the side, the robot might be turned a little bit. So it's still going to be shoot or back up a little and shoot. But then we might be able to just keep backing up on that angle, make one turn towards the loading station. Or again, on this side, if we're here, back up, make one turn towards the balls on the floor, and then try to pick them up, and then go back. We may or may not be able to go back to the middle. There is a benefit kind of to like going back against this flat edge, which is that you can slam into it to reset your position before you back up a little bit. So that can help. And then the craziest auto mode, of course, is you could shoot, and you could either go over the bump or through the under the bar here, and try to pick up more balls from the middle and come back. Or there's a good chance that really good robots on the other alliance might be doing the same thing. So you could just drive through here and try to just get in their way after you shoot your initial 8 balls. So there's lots of auto mode options. We're not going to do every single one of them, of course, here. We're going to do a few examples for auto modes that would be good. And then it'll be up to you to choose which of kind of like those things we talked about or your ideas that you want to put in. But we should have enough different steps here that you'll be able to put that all together and make any auto mode you want. OK, so let's get some more tape marks out. Let's go back down to the marked up, dimensioned up field here. So that auto mode line that we want is 156.61 inches away from the wall. Okay, that is 156.61 if we divide by 12. I think that's about 13 feet. So it's about 13 feet from the front edge of the hub to the driver station wall, which is where you would want to be to load these balls. And this section here, we have the dimension to the front of the balls is about 27 inches. So the first ball is about 27 inches closer, or about 2 feet, 3 inches closer. So that 13 feet becomes like 11, 10 feet, and I don't know, 8 inches or so. And then the other number we want is how far do you have to move out to get to these balls or to get to the center line of this. So the center line of the human station is 26 inches. So again, that's going to be 2 feet, 2.2 inches or so off the wall. And then the full distance to the center of the field is 158.84 inches. So if we subtract 26.22 from 158.84, it's like 132 point something. And 132 would be about 11 feet. So you should get your exact numbers, but I think it's going to be about 11 feet from the center line of the goal to where you would want to be to load those balls. And on the other side, it's 82.84 to the center of these balls. And the balls are about 6 inches, so it would be another 18 inches less if you just want to hit the corner. But I think like driving through the middle is probably the best chance of picking them up. So in this case, 82.84, so it's that 158.84 minus this 82.84 should give us this dimension here. And that, I think, is about 70, it's 84 and 84, so that's 76 inches. So 76 inches is 6 feet 4 feet 4 inches. So that's about how far we'd have to go this way. Now, let's see what we can do in our area here. All right, so if we say the front of this is sort of like that front of the hub, and all the rest of the hub goes back and off to the side, we can kind of get our, and maybe we'll cheat it a little bit, but if I do the starting line kind of like here, let's see, I would probably, if we didn't need room for the cameras and everything, right? Like I would probably move this out towards the middle of the room, spread stuff out so we have room to go both ways. Here it's going to be really hard to work on this side. Like if we had to start over here because we got this little like closet in the way. But since I put this right on the front here, what we can do is, I think I can just kind of bring this forward a little bit until it's on that line. That's pretty close to the line. All right, so in our case, we can do the initial one, the easy one, which is starting flush up against this and trying to make our shots and seeing if we have to back up or not. And then if I extend this line out a little bit more this way, we can also see what it might look like. We'll probably have to change in our mind to say instead of the goal going this way, the goal goes this way. But we could start, here. Maybe just on the line, might have to move these clamps and stuff when we do it. But if we're starting just right on the line here, aiming for the side of the goal, then we can back up and be going towards the human player section. On this side, if we did the same thing, we would then be backing up and going towards the floor load balls, which would be somewhere over here. And we can see that we can kind of get a few notes here. So if we say the center of our goal is, you said it's 41, right? So the center of the goal would be 20 and a half or so. So it'd be somewhere like here. So if this is the center of our goal, we can maybe make a mark, and this is like our center line. And you should probably spend a little bit more time being precise with this. I know that we have a full field that we're going to be able to visit later once we have our test programs in. So we'll be able to do a lot of tuning there. And it's going to be a lot easier for us. But if you don't have that option, you should make these as accurate as you can. All right, we said it was about 13 feet to the wall. And I think, unfortunately, we probably don't quite have 13 feet of space here. Yep, so this is 11 right here. I'm going to do a little mark at 11. So 11 is like the front of where the ground balls would be. So this is 11 feet. And then 13 would be back here. So this is 13. And then, let's see, what did I say? It was about, let me orient myself. So the ground load balls, as you face the goal, the ground load would be on the left, and the human load section would be on the right. So it was about 6 feet, 4 inches to the ground load balls at 11 feet out. And I think I did kind of the edge of the tape to it. So 6 feet 4 means the start of our ground load area is going to be 6 feet 4, 76 inches right here. So this is the corner of ground load. And then that ground load area would continue off this way, underneath the table that's back here, and would continue off this way, that extra 2 feet until it gets to the back wall, well, 2 feet plus a little. So this is sort of like the corner. That's going to be kind of scary for us to go all the way to, but you can imagine there would be a ball right here that we might want to try to pick up. And then the other one is going to be even harder to get to because that is also, what was that one? That one was also, that was the 100 and, oh, sorry, that was 26.2, 158 minus 26.2. So that's 11 feet. Going out this way. And I think we have no chance at kind of doing that. So that would be 11 feet. It's like, you know, behind all of the cameras and stuff. So we might work on that auto mode. We might do like sort of a start backing up in that direction and maybe a rotate, but we're going to have to adjust those numbers for sure once we get to a bigger space. All right, so that's good. We kind of have a feel for like, you know, how the field is laid out and where things actually are. Let's just start with the simplest auto mode that, you know, kind of does something. And that is if the robot were right, well, I guess we would want to be in the center, but we'll kind of cheat it off to the side a little bit so we can hopefully get some in the actual bucket. But if we're right on the line, like this, so my bumper is just over the line, then we're looking to make these shots. And again, remember, we can start with 8 of these balls, 8 fuel in the robot. So we'll toss a few in. We definitely have some work we have to do to get our shooter working, which is going to be the next step. So that's 6. We'll start with that. All right, so the plan is we have to go ahead and code our shooter. Then we can put it in this position and shoot and see if it goes in. If it does, great. We just have to tell it to spool up the shooter and shoot until all the balls are gone and we're done. This auto mode is done. If it hits and it doesn't quite clear and the shot isn't good, I think we might end up in a situation where we want to back up a little bit so we get a better angle at the goal and then shoot. So that's our first auto mode. I guess we got to get the shooter or the launcher mechanism working here. So let's go ahead and jump back into our code. All right. So there are a few things we need to get going in order for our launcher to work. And that is, well, first thing first, let's scroll all the way up to the top. I don't think we need any new imports because this is just using the SparkMax that we already imported and are already using. But down here, where we are sort of creating all our motors, I'm going to go below our drive motors, leave a space. We now need to create our next 2 motors. And if you remember, there is one motor that controls the feed and one motor that controls the intake roller and the shooter wheel, or the launcher wheel. All right, so we have those 2 different motors that we have to create. And those are going to look the same way as the other motors we created. We're going to do a private. We're going to do a final. It's going to be a SparkMax. And now we have to name them. So The intake/launcher roller was in 5, so let's do that one next. I guess I'll call it intake and launcher roller. I mean, I'm going to autocomplete it from now on, so I guess it can be as long as it wants to be. I don't have to type it anymore. So that seems good. I guess I didn't mention this either. Like, I'm doing this kind of like camel case where I capitalize every word after the first. Just makes it a little bit easier to read. You don't have to do that if you don't want to. And if you prefer, some people like doing it where you do underscores in between the words instead of worrying about capitalizing stuff, and that's fine too. All right, it is going to be a new Spark Max. We said the intake and launcher one is on 5, CAN ID 5. And then, of course, the motor type is K brushed. Cool. And we need another one, private, final, Spark Max. And this is our feeder roller, let's call it that, is a new Spark Max. This one is 6. And it is also a motor type .K brushed. All right, so now we kind of map those two things. We can, I think we got to do a config for them, and then we can start using them. All right, let's go down to where our drive configs are. I'm going to go below that. Another thing that you sometimes can do is like this whole section here is doing drive configs. So you could do like this and be like drive configs. And then we could come down here and do fuel/launcher configs. And this is just another way to kind of keep stuff like organized, so you can see, really visually now, like if I realize there's something wrong with my drive configs and I got to come in and find the invert stuff, it's a little bit easier to find it because I have this big label there. But that is all preference. OK, so for these configs, we have to make a new config. So we're going to do a Spark Max config. Right? Just like we did up here, the same line of code again. Don't cover it up, but we did this line of code. And this is going to be our feeder. Let's do the launcher config. Launcher config. Remember that means intake and launcher. Equals new Spark Max config. OK, and a lot of the things that we're doing on this config are going to match up with what we did for the drivetrain as well. So the first thing is we can do launcher config dot smart current limit. And again, 60 seems like a pretty safe number to use. It's actually probably fine if you skipped all the smart current limit steps. It would probably be OK. And then this motor, we could test it and find out that it's backwards, but I'm pretty sure this motor is backwards. So let's just go ahead and do launcher config dot inverted, and let's go with true. We want to invert the launcher. OK, and then after this is all set, we want to now write this to the motor. And then the line to write it to the motor is we do what do we call it? Intake and launcher roller. The name of the motor that controls it. Dot configure. And launcher config, it got it, it knew. It was right there for me. If not, go ahead and type in launcher config. And then these things are going to be the same as before. So reset mode dot k reset safe parameters. And the other one is persist mode dot k reset or k persist parameters. All right. And then I guess let's do a Spark Max config again. And this is going to be for the feeder config. It's a new SparkMax config. And this one, I think the only thing we really need is the current limit. So we could probably skip this one altogether. We probably could have done a thing where we use the same config multiple places, but let's just go ahead and do a, oops. I feel like the palm rejection on my laptop is not very good. All right, this is our feeder config dot smart current limit 60. And then that's the only thing we're going to do. So then we're going to do our feeder roller dot configure, feeder config correct, and then once again reset mode dot k reset safe, and persist mode dot k persist parameters. Okay, so now we have the ability to start using this motor. But, well, let's just go ahead and test it really quick, and then we'll come back and we'll make another change. All right, so down here in our auto mode, let's go ahead and use our default auto mode again. In this case, I'm going to not drive at all. So this line of code where we're driving, I'm just going to make that be 0 and 0. So we don't want to move. But let's say for like 3 seconds now, so we have a little bit more time to work with our launcher, we can do some other things. So we can do our intake and launcher roller dot set, and we could do set voltage if we wanted to. Okay, and then we can pick a random voltage for right now. We just want to see it spinning. We'll do something pretty high. Let's do 10. I think 12 volts is, again, kind of our nominal maximum. So we'll go ahead and do 10 volts here. And then I guess let's do one at a time. So we'll do the intake and launcher and see what happens. Now, I guess we have to run both at the same time. So we're also going to do the feeder roller dot set voltage. And this one, I think we can do, well, whatever. Let's just do 10. Let's do 10 on both for now. All right, so that's going to have them both spinning. I don't know which direction they're going to spin, but let's go ahead and deploy this. We're going to get 3 seconds of robot action. So this will either launch a ball or intake a ball or eject a ball. I'm not really sure which. But our key right now is we just want to see a move, and we want to know we're kind of on the right track. All right, we got real log. We're going to go back to our autonomous mode. Let me hold one of these. All right, so maybe we're launching here. Maybe if the intake is going in the other way, I might feed a ball in and see if that works. But for the most part, let's go ahead and enable. And we have 3 seconds of, the first time I'm just going to watch, and then we'll enable it again. And the second time we'll play more. So let's enable it. Here we go, 3, 2, 1. I'm going to disable it. You will notice that it didn't stop because in the else case, we didn't actually tell it to turn off. But let's throw a couple balls in. So a few things that I noticed. The first thing is watch really carefully the first ball that we launch. I think the first ball that we launch is going to go really weak, and then they're going to start building up and shooting higher and higher. That's what I want you to watch for this time. But it looks like when both are positive, both are forward directions on our 2 motors, it's going to launch balls. All right, so we're going to do this again. Enable in 3, 2, 1. All right, so that time it wasn't quite as pronounced, but I think I still saw the first ball went to maybe only here, and then the next few balls went, about that high. And I think what that is it takes some time. Remember we put that big steel flywheel piece in the middle here in these wheels? So it takes some time for this to get ramped up to full speed. And if the first ball feeds up quickly, this has not reached its kind of maximum speed yet to be able to launch high. So now there's a few things that we can do to fix this. And there's a bunch of different states that we want things to go. So first of all, when we're launching, right, we need the feeder to be going this way to push the balls out. We need the intake to be going this way to push them up. And then the launcher wheels need to be going this way to launch the ball out. When we're intaking, we need this to be going the opposite direction. Our intake here should be going the opposite direction, and our feed should be going the opposite direction, so the ball goes into the hopper instead. And then we need a situation where we're spitting out. So in that case, the feeder motor is going to go the same direction to push it back to the middle, but then instead of having our intake pushing the ball up, we need our intake spinning the opposite direction to feed the ball back out. So we got to kind of set up for all three of those cases. And it turns out, based on what work they did with the KitBot, it's a little bit sensitive to the specific voltages or the specific amount of power that we send. So we don't want to just go full power on both to bring the ball in, full power on both to spit the ball out, although maybe that one we do, and then full power on both to try to feed it up and launch it. Because I think in that case, you might be feeding it too fast. It might jam. Same thing when you're trying to intake the ball. If the front roller is going too much faster than the feed roller, it might accidentally push the ball up into the launcher wheel. So when you're intaking, you might end up shooting some balls, launching some balls, instead of storing them inside the robot. So let's take a look at our code. There is kind of a trick to this, and that is we can go through when we're doing our code and just remember the numbers and put the correct numbers everywhere. But we're going to use these numbers in lots of different places. So it's to our benefit. And by the way, before I scroll up, remember in the less than 3 seconds we turn the motors on. Remember I told you we need this line to make it stop driving? Well, I didn't add that turn off for these. That's why it went forever. We would need to add this dot set voltage to 0 down here. But let's go up to the top. Not quite the top. Let's go to, here. We did our configs here. I think there's one more thing that we want to add here. No, actually, let's go even farther up. Okay, and so before robot, after all of these private final objects that we did, I'm going to do a section here, and I'll go ahead and label it off. This is going to be this is our fuel mechanism parameters or something like that. And we'll add some more of these dashes. All right, so what we can do is instead of saying like, hey, 10 is the right voltage to do this, it should be 10 for the feed and 12 for the wheel, or it should be 9 and 5 when we're intaking, and 12 and 12, negative 12 and negative 12 when we're ejecting the balls or spitting them back out. We can save those values here, and then we can use the name that we have here in our program later. And then if we find out that, our intake value is wrong when we're trying to intake the ball, it needs to be a little bit bigger. Instead of having to go through our program and find the 5 different places where we put that number or more, we just change it once, and then because we're using that variable name everywhere else in the program, it's going to carry through. So let's get started with those. There are a bunch of different things that we need. So first is, remember we have a few different states, right? We could be intaking. So so it's going to be a private, it's going to be a double, and it's not going to be a final. So the difference here is private still means it's only usable by this robot, by this area of our code, which is our whole code. Double means it's going to be a double precision floating point number. That just means we can use decimals. That means it's a number that can have decimals. There is a limit, like a maximum size that it could be, but you're not going to get close to it, so don't worry about it. And we're taking the final off. Actually, no, this could still be final. Hold on, because this isn't going to change. So hold on, let's go back. Let's do this as a static final, because it's not going to change. Whatever number we put in here is always going to be the same. Because we're going to say, hey, voltage is 9 when you're intaking. It's always going to be 9 when you're intaking until you change it here and redeploy the code. So we have several different states of being. When we're intaking, right, we have, let's say, intaking is our state. And I'll do an underscore. And this is weird, but I like my static variables that we use as parameters to be capitals. It lets me know that when it's written this way, it's a variable that we can change or an object that we're controlling. When it's written this way, it is a parameter that we're just saving a number in. You don't have to. You can type this however you want. It could be lowercase. You could do the camel case. with capital letters like I was doing before. But this is just another way for me to keep stuff straight. So when I see it later on in the program, I'm like, oh, it's all caps. That's one of my parameter variables. All right, so when we're intaking, we need to have our intake/launcher value. So I'll call that our intaking. It's weird if I call it the intaking intake value. So I'm just going to always call it launcher, maybe. Nah, let's do intaking intake. And this is going to be our voltage. Okay, and that is, I think that's the same name that first called it in their version of the code. So we might as well stay consistent there. So intaking intake voltage. This is the voltage we want to send to our intake/launcher motor when we are in intake mode, when we're in floor loading mode. And we're going to say that's equal to, and the number they tested and was a good starting point was 9. So when we are intaking balls off the floor, we're going to do it at 9 volts for the intake/launcher motor. We're going to do another one, private, I don't want this to be caps. In fact, this can't be caps. Static final double. And this is going to be our intaking, this is our feeder voltage, I believe. Yep. Intaking underscore feeder voltage. There we go. All right, and this is going to be equal to -12. All right, so that one has to go the opposite direction, right? Because when they were both positive, that would have fed balls out from the hopper. Making it negative should feed balls into the hopper. All right, so that's 2 of our settings. That's our intaking settings. Next up is we have 2 more. Maybe I'll leave a space. We have private, static, final, double. We're just stacking everything here. All right, the next state is launching. So we have launch, let's get some cap locks going here. Launching, underscore, and then I guess it's, in this case, it's going to be our launcher voltage, underscore voltage. So what voltage do we want to send to the wheels, the launching wheels / the intake, that motor? And that is going to be, looks like it's 10.6 volts. So not quite full power, which means if your robot ends up shooting a little too weak, if it's launching a little too weak, we do have some room there to increase that power up a little bit. All right, then let's do private, caps lock again, private, static, final, double. And this is going to be our launching feeder voltage. So when we are in launching mode, what voltage should we send to the feeder motor? And that is going to be a 9. All right, then we have one more set of variables. Now you might think, oh, we need the eject variables. Turns out for eject, we just take the intake values and we reverse them. And that should eject the ball out the front. So we can just use those in reverse when it's time to, if we get jammed or we want to feed the balls to somebody else. All right, but if you remember when we were launching, that first ball went a little short. Like that was lower than the rest, or the first 2 sometimes. I think the first time we did it, the first couple were weak, and then it sped up. So we need to have another situation where we want to spool up the launcher motor without feeding balls to it yet. And so we're going to call that our spin up time or spin up period. So we're going to do 2 more of these kind of constants that we're using here. And we'll call it spin up. And this is going to be, feeder voltage. So what voltage do we want to send to our feeder motor when we're just spinning up? And the answer is, well, we're going to do -6. So by using a negative number, that should stop the balls from exiting the hopper. It should just hold the balls in. And then when we go to the positive number later, that will feed the balls in and it will make it, around the whatever, the whole system and launch out the front. Now, the launcher doesn't need a different value because we just want the launcher to get to the value that we want it to get to anyway. So when we're doing our spin up period, the launcher wheel, the launcher / intake motor is just going to go at the 10.6 volts that we want it to have when we are launching. Okay, and then the last thing is it takes some amount of time for that wheel to spool up, and we might want to be able to adjust that variable as well. So we'll do one more line for private static final double. And this is going to be our spin up. I guess I'll do this cap, spin up, and then let's call it seconds. So how many seconds do we need to spin up before we're ready to actually start launching? Let's start at 1 second. That is, again, the default value, and then we can test and see if that needs changing or not. All right, so now that we have these values, if we go back down to our code down here, instead of saying, let's send 10 volts, if we want to be in launching mode, right, then for the intake launcher and roller, we would send launching launcher voltage. And that launching launcher voltage, right, up here where we set it, launching launcher voltage is 10.6. Okay, and then same thing for feeder. But actually, what we want to do here is let's change this. So for the first 3 seconds, first of all, not 3 seconds. So this is going to be an actual auto mode now. So let's go ahead and do a couple slashes here. Our default auto mode up here. So our default auto mode is now going to be, this is going to be start in front of goal and launch, and that's it. Okay, so now we can actually start building this auto mode out. So the first step in this auto mode is we said we don't know if we need to back up or not, so our first step is just going to be let's spool up that wheel. Give it that time to spool up, then let's start launching. Let's put the robot in position and see if it clears and see if we need to back up or not first. So this first step, and this is what I'm going to do. So this first step after that parentheses, I'm going to add a note here, and this is spool up. Well, I guess we called it spin up the launcher. The launcher. All right, the launcher. All right, spelling. Cool. How long do we want this period to run, right? It should run for our spin up seconds variable, which in this case is 1 second. So this is basically saying if autotimer.get is less than 1 second, we should be in spool up mode, which means our feeder roller should also be in spin up feeder voltage. So remember I told you the launcher voltage, we want it to get to launching speed, so we just set it the same even when we're in spool up mode or spin up mode. But the feeder needs to be in spin up mode, which keeps the balls from falling out of the hopper, keeps the balls in the hopper. So this is step one. We already have our drivetrain here. That's cool, we'll leave it. Now, the next thing we want to do is go in between. So I'm in between the closed parenthesis or the closed curly brace for the if and above the else. We need another step. Step one was to spin up the launcher. Step two is going to be to start launching the balls. In order to add another case here, we can't do another if, but we can do an else if. Okay? And the way it works is first it checks if this is true. If this is true, it runs this code. If this is no longer true, which in this case means the stopwatch is past 1 second, then it's going to check our next else if. And if that else if is true, it'll run that code. If that's not true anymore, it would check another else if it existed. If there's no more else ifs, then it would run the else case. So in the else if, what we're going to do is we're going to say, hey, well now, if our timer, autotimer.get, let's look back at that stopwatch. If it's less than, how long is it going to take us to launch 8 balls? Let's say, I don't know, let's give us 1 second a ball. So we're going to give ourselves 8 seconds to launch the balls here. If I put an 8, though, that's not 8 seconds, right? Because for the first 1 second, we're running this code. Then we start running this code. So this code down here is not going to start running until 1 second is already passed. So really, we want this to be between 1 and 9 seconds if we want it to run for 8 seconds. We got to do an open curly brace, hit enter. And now, essentially, you could just take all of this and copy and paste it into here, because that's what it's always going to be. Every step, we're going to give our intake and launcher motor a value, we're going to give the feeder roller a value, and we're going to give our drivetrain a value. But I'll retype them this time. So it's going to be intake and launcher roller dot set voltage. and it is going to be our launching launcher voltage. That does not change. Now our feeder roller, so we do feeder roller dot set voltage. That is going to change because our spin up time is done. We're doing spin up feeder voltage here, but now it's time to do launching feeder voltage. So this is going to now become launching feeder voltage. And then in theory, because our drive is off here and off here, we don't technically need to change this, but I'm going to go ahead and add the my drive in. This is a waste of time if we find out that our shots work perfectly and we never have to drive. But if we have to drive, we're going to be saving some time. All right, so I'm going to just set these both to 0, just to be consistent. So now, if we review our code, right, we come into auto mode. If we have default auto mode selected on our dashboard, then we're going to run this code. And at the very start of autonomous, we're going to start and reset our timer, so our stopwatch is at 0. If that stopwatch is less than 1 second, so for the entire time it's less than 1 second, we are spooling up. We're spinning up, so our launcher motor is going to its power, giving it time to get up to that speed. The feeder roller is spinning backwards to hold the balls in. That's our spin up feeder voltage. And tank drive says don't move. After 1 second has passed, now from 1 second to 9 seconds, 8 total elapsed seconds, but from 1 second of auto mode to 9 seconds into auto mode, we move into this case, this else if, which we keep launching at the same speed. But now we flip our feeder motor to launching value, which is now +9. So it's going to start feeding balls in. So for those 8 seconds, we should be launching balls. And then we stop. We always stop driving. And then in the last case here, we do want to turn everything off. So let's add our intake and launcher roller dot set voltage. In this case, it's just 0. We don't have saved values for stop. We're just going to use 0 when it's time to stop. And then feeder roller dot set voltage, also 0. Should just stop. All right, I think that looks good. Once you have that code, go ahead and deploy it. And while that's deploying, I'm gonna be collecting the balls that rolled all over the place and get them back in the robot. So that's 5, this is 6. I think we're allowed to start with 8, so let's grab 2 more of these and put them in here. And then we talked about, okay, the robot can start, or should start, or must start, so that the bumpers are a little bit over the line. So I'm like kind of halfway over the line here. And we're, pointed up towards the goal. Remember, this goal is big, so even if we're off angle a little bit, it's probably fine. But I can, from behind, try to straighten that out. The other thing that you'll notice is down here, you can kind of set these balls in here in a variety of different ways. Like if I really wanted to, I could maybe, I could have this. I could have a second layer in here. This is something, as you're doing stuff, you should test this, right? And if like stacking them up like this ends up being bad, don't do that. I definitely would not like wedge them down so they're sitting flat. I don't want that extra, force in there. So, maybe we'll just gently set that one on top. This is a situation where you can prevent jams because you're allowed to physically do some things. Of course, we do know for 1 second this is going to be going backwards. And so that might unjam it, but it might also change the way that the balls are laid in there. So just keep that in mind. All right, looks like it's lined up. Looks like our code has deployed to the robot. So I'm going to bring up my driver station, make sure we're still on default auto. And let's enable it and see if these shots go in. So we're looking for 2 things. We're looking for 1 second of spool up time before the balls start launching. And then we're looking to see if 8 seconds is enough time for all of the balls to launch and end up in the goal. And the third thing is we're looking to see if they make it over the edge of the goal and look like they would score. All right, let's do this in 3, 2, 1. All right. So much just happened. First, I disabled the robot, so it's safe. Second, we still have 2 balls in the robot, so that was not enough time for our launching. We probably want to increase that maybe to 10 seconds. I don't know. Next, I watched several balls hit here. And that means, right, because the ball is going on an arc, if it hits here, that means it's hitting on the upward part of the arc, which means if we back up a little bit, it would keep going up and go in. So I think of the 6 balls that launched, we had 8 balls in the robot, 6 of them launched. 3 of them I think would have gone in, it looked like, and 3 of them banked off the side. There was like a ball hitting another ball that was bouncing back, so my count might not be right. You can obviously go back and slow-mo the video, and you'll know the real answer, and I will have to live without ever knowing. I guess I could watch the video too, so then we would both know. Anyway, we need to back up a little bit before we launch, I think is the moral of the story here, and we need to give the robot more launching time. So I guess I'm over here. I'll drag the robot back with me, but let's get back into the code and make those changes. And this is why I was not super upset with having the tank drive in places, because I kind of thought we would need to do this. All right, so first step is we have to back up a little bit. Now, what's interesting is if we back up for 1 second, like if 1 second is the right amount of backup, and 1 second is how much time we're using to spool the motor up, we could be backing up while spooling the motor up. If it's not the same, we will have to add another step. But let's try to combine them, because I think 1 second could be good. We just have to choose kind of the right speed. So if we do 1 second and we back up at, let's do that let's try 0.4 and 0.4. And by 0.4, of course, I mean negative 0.4, because we want to, oh no, wait. The robot intake is the front. So we actually launch the balls off the back of the robot. So 0.4 is the correct amount. We actually aren't backing up. We're pulling forward away from the goal. So 0.4, 0.4. That means for our first 1 second, we'll be driving away. Now, if that number is bad, if that doesn't work out, we could potentially reduce this number a little bit. But if it's still not right, then we're going to have to add another case. And that case will be like, OK, drive for this much, and then spin up, and then start launching. OK. The other problem we said was we need more time to try to make sure all the balls actually launch. So instead of 9 seconds, let's do 11. That means we now have 10 seconds of launching time. I think that's all the changes we have to make. So let's go ahead and deploy the robot code. And as always, while it's deploying, I'm going to go on a scavenger hunt. There's 4. Uh, 5, 6, 7. Is there one in it? No. Well, we got this one. All right, and then get back on the line. One of the things when you're doing these tests, I mean, obviously we're not moving much, but if I start on an angle like this, that is going to greatly affect where the robot backs up to. So, try to make it straight, try to make it consistent with how you line it up. All right, seems good. And code is ready, so let's go ahead and bring our driver station back up. Default auto. All right, we're going to do autonomous mode. So now for that 1 second, when it's spooling up, the robot should also be pulling away from the goal to give us a better angle. Let's try it. 3, 2, 1. OK. Interestingly enough, this time it launched all of them. They all cleared the front edge. What I couldn't tell, some of the ones were hitting the wall. And I don't know how high or how low they were hitting the wall. Some of those balls might have been going over the entire goal. It's possible. I think they looked pretty good. But nothing went in the bucket. So we have nothing that's going kind of in the first 13 inches of the goal, which means I think we could back up a little farther and kind of give ourselves, what we want is the default ball. If we took the location of all the balls that landed, we want the average spot to be the middle of the goal. And I think our average spot right now is the back of the goal. We can fix that in a few different ways. We can fix it, of course, by changing our launcher motor speed. But I think we'll be better served by keeping that launcher motor speed, which is working pretty well and keeping consistent shots. But let's just back up another foot or so, and that might help center these a little better. So let's do the code first. And while it's deploying, I will reset up. All right. So in this case, because we only have 1 second of movement, I need to change the speed that we're moving during that 1 second. This is usually not the best way to tune these values in. So again, we might end up in a situation where if we need to do this for longer, actually, let me think. OK, so we have spin-up speed, and that's our minimum spin-up speed, right? If it spins up for longer, that's OK. We'll still be at speed. So what I could actually do here is say, hey, we're going to go our spin-up speed plus, let's say, like 0.2 seconds. So now we're going to back up for 1.2 seconds instead of 1 second, which should, in theory, be 20% more distance. We currently backed up about 20 inches. So 20% more would be another 4 inches. So let's try 1.5. That'll go, instead of 20 inches off the line, that should get us to about 30 inches off the line. Now, it's not going to be exact, but that is a good ballpark guess. All right, let's go ahead and, once again, deploy robot code. And while it's deploying, we'll reset the robot. 1, 2, 3, 4, 5, 6, 7, and 8. They were all back there. That's a good sign. Make sure we're kind of the same amount over the line. Looks pretty good. And code is ready. Let's bring up our driver station. Still default auto. OK. We're going to go in 3, 2, 1. Disabled. OK. The other thing to note here is, obviously, we launched all the balls twice. 10 seconds is more than enough time so far. But I think the first time where they didn't all launch, they kind of jammed up a little bit. So we won't know for sure until we keep testing. But what I would say is this. If you are only doing this backup and launch auto mode, you have 20 seconds of auto mode. You could launch for 10 seconds. You could launch for 15 seconds, and it would be fine. So you can increase that number. If you have nothing else to do, you don't really need to cut that number down. Leave it a little bit big. Make sure the balls launch out. Now, that time, when we were launching, 4 of them ended up in the bucket. One of them might have gone in the bucket and bounced out. I don't think I saw any. Maybe one hit the back wall. So that feels like, if anything, we backed up slightly too far. We might want to move forward a couple inches. So we could adjust that number, but that's pretty good. I think all of those shots would have made it in. Nothing is close to hitting. So, honestly, pretty happy about that. OK, so now that was our first auto mode done. Let's learn how to relabel our auto modes so that they make sense when we look at this list. Because if I have default auto, my auto, auto 2, new auto, like how am I going to know what they do, right? So we have to be able to change those labels. And so we're going to learn how to change what shows up here in this smart dashboard and potentially add more. So let's go back to the code. OK, so let's scroll all the way up. I don't know. I'm going to go to the top, and then I'm going to start scrolling down. So in public class robot extends timed robot, line 25 or so, we have these variables that we're creating that are going to go into our auto selector, our sendable chooser. So first thing is we have kdefault auto, which is labeled as default. This is the label here. It's kind of like what's going to show up on that smart dashboard. So we can continue calling it our default auto. But label-wise, let's add something. Let's do default auto : and this is going to be back up from hub, and then launch. Okay, and then I think I'm going to have to type this again, so I'm going to copy it now, but if you have to type it again, that's fine. All right, now if we scroll down to this section, we have set default option here. I can never remember which of these texts are what show up on the smart dashboard, so I always make it the same. So our option is now called default backup from the hub and then launch, but our variable name is still going to be kdefaultauto. All right, and then basically this is like we're creating the menu buttons. I think this is actually the one, the text that we want to change. So we create our two menu options, and then this last line puts it on the smart dashboard. Then if we scroll down, this is going to print out the selected auto, and then this will be the name. So this, I think, is the first name that we put in, and the other one was the second name that we put in. But that should be the only change we have to make to see this update. So let's go ahead and deploy the code really quickly. We don't need to run it. We're just going to see if that's working. And then we can figure out what we want our next auto mode to be. All right, looks good. Let's jump over to our smart dashboard here. And you can see now, default case, backup from hub, and then launch. Perfect. All right, so now let's start our second auto mode. And what should our second auto mode be? We have a bunch of choices here. I think that there exists a world in which we want an auto mode that starts on the side and just launches. It doesn't even need to back up. So if we go this way, what I can do is I can put the corner of the bumper over the tape line. Again, I'm imagining there's a bump here, and we're not allowed to be touching the bump, so I can't be like way over the tape line. But if we're just corner on the tape line here, one of the things that helps is like to know the positioning, the distance here. I think you are allowed to have like a thing that you can carry out, like a ruler or something, to know the distance that you are. So you could have a stick that's like, OK, if we put the stick from the edge of the hub, it should be this far. I don't have the edge of the hub. Remember, the edge of my hub is actually somewhere over here. So we might need to move farther over. Actually, let's pretend like this is the edge of the hub now. Before, that was kind of the center of the hub. But let's pretend like this is the edge, and it all stretches out this way, just because we're a little bit tight on space. So if this is the edge of the hub, I could say like, OK, well, it is, I want to be one big step away. Or I want to be, if I wear the same shoes every time, I'm going to be 3 shoes away. Or I think you are allowed, as long as you don't delay the start of a match, you are allowed to have a tape measure or something. But I think if you have like a stick, like a meter stick, that might be better with marks on it. But just so I can be consistent, this corner of the robot is roughly 3 feet away from the edge of the hub. And what I can actually do is I'm going to put a mark here at 3 feet. So sort of like that's where I want the corner to be. Now, you're going to have a decent amount on this one because we're not driving anywhere afterwards. You have a decent amount of adjustment here. As long as you're in a good spot to be able to hit the goal, you're in great shape. And if you remember last time, the distance that we backed up was about 30 inches. I didn't actually check the final distance afterwards, but it was about 30 inches what we were aiming for. So if we start 36 inches away, the front of the robot is going to be kind of close to 30 inches away, because that'll be on this angle here. So we'll be, again, maybe 30, maybe 36 inches away, depending on how we aim it. But that's pretty close to working based on what we've seen. So if we bring this robot, again, back up to that corner, and then I would aim roughly at the goal, as it were. And if this ends up shooting too far or too short, right, of course, we can move where that corner is and still be aimed at it. And we have a decent amount of space. Like if a robot wanted to start in the middle, there's room for another robot to start in the middle. They'd actually be over a little bit, because again, if this is the edge of the hub, it goes to 41 inches over for the goal and 47 or something for the base of it. So they would actually be like centered here. So their robot would be like this. Plenty of room, even if we have to get closer. And their robot could, launch in the hub, and then maybe they back up and do the little hanging bars back here. So this is kind of our way to stay out of the way, be a flexible teammate that can make this stuff work regardless of who our teammate is. So let's see if we can do code for that. And let's do all the pieces as we go. So at the top of our code, we have this KCustomAuto, my auto. We're going to start changing these names now. So instead of KCustomAuto, this is going to be K, and we'll just keep the K there because that seems to be the format that they like. This is going to be K launch from side with no driving at all. And we can label this. This is going to be me pressing the print screen button, maybe? All right, this is going to be launch from side and stay. And again, we're going to need this again, so I'm going to copy this bit here. And remember, it's K launch from side. If we scroll down, now instead of my auto here, we're going to change it to launch from side and stay. And instead of K custom auto, we're going to change it to K launch from side. All right, so now we have it set. That new name will show up on the dashboard. The last thing we have to do is, in auto mode, K custom auto is no longer a choice, right? So when I said we have this switch, we said look at what M auto selected is. This has to match one of the options, and our option is now K launch from side. Okay, and we can do our / here. We could be more descriptive. Launch from side is pretty descriptive already, but this will be start from either side of the hub aimed at it and launch the balls, no driving. So this will work on the right or on the left, because and again, we're just pointing the robot at the hub with the right distance away and telling it to launch. Okay, so let's do the code for that. Now, there's a really good chance you might just want to copy and edit the stuff, because again, each section we do is going to have this, and it's going to have if auto time or something. But I'm going to do it all from scratch just because maybe that helps you understand what I'm talking about a little bit better. So first step is always if. And the if is going to be, hey, we need our spool up time. We don't have any driving, so it's just spool up time. So if auto timer.get is less than our spin up seconds, then we run this code. And we can even label this step. This step is going to be spin up the launcher. Launcher. All right. I'm going to do the next. I'm going to do the framework, and then we'll come back in and we'll fill in what should happen on each step. So then we have else if autotimer.get, and you need the parentheses, don't forget, for autotimer.get, is less than. And then this was our how long should it take to launch, right? And remember, we have 1 second for our spool up. Actually, that reminds me down here, when we added this 0.5 seconds, that means this first section runs for 1.5 seconds, which means this section doesn't run for 10 seconds anymore. It runs for 9.5, which was still plenty, so that's great. But here, let's go to 11. So that should be 10 seconds of launching time. Again, we're not doing anything else, so we might as well make sure the balls get cleared through the system and all get launched. And we need our open and close parentheses. And then, so this case, I can do a comment here. This is launch the balls, or the fuel. And then finally, we always need that, new line, we need that else case. This is if neither of these other things are true, which means we are now more than 11 seconds into auto mode. This is turn everything off. All right, so let's build it now. What do we need in this first section? Well, honestly, it's everything that we have here. So it's going to be, set the intake launcher roller to launching voltage, set the feed roller to spin up voltage. And then we could turn the drive off, but actually we're not going to drive at all in this one, so we can just ignore drive. So intake and launcher roller dot set voltage. And this is going to, again, be our launcher voltage. And we're going to do our feeder roller dot set voltage. And this is going to be our spin up feeder voltage. So this is our spin up period voltages. Then down in the next case, we're going to do our intake and launcher roller dot set voltage dot set voltage. And that's going to be launching launcher voltage again, so same thing that we did before, right? The voltage that it should be when we are launching. And then our feeder roller dot set voltage is going to be our feeder launching, our launching feeder voltage. All right, so remember, it's just, and you can hover over this. This is 10.6. Spin up feeder voltage is -6. So it's the same thing as me just writing 10.6 here and -6 here. Same thing down here, 10.6, and this one is now 9.0. So it's the same thing as writing 10.6 and 9.0. But again, when we find out that, oh, our launching voltage for the wheel is just a little bit too weak, we want to increase it everywhere, well, I would already need to change it in 2 places for this auto mode and in 2 places for this auto mode. And if we do more auto modes, that's 2 more places for each one or more. And if we have it in teleoperated mode, it's there. So it could be like 10 places in your code that you have to change it. So if you're like, oh, we need a little more launcher voltage, do you want to find all 10 places in your code and change it? Or do you just want to go to the top where that one variable is and be like, oh, let's make it 10.7. Fixes it everywhere. So that's the reason why we're doing it again, just to reiterate. OK, back down to our code. The last thing we have to do is turn everything off, which means intake and launcher roller dot set voltage to 0, and feeder roller dot set voltage also to 0. All right, let's deploy this. And while that's going, let's see. I got to find 3 more of the balls that ended up somewhere. Are there any in here? Nope. I found them. All right. Code is good. Let us go to our driver station and our smart dashboard. And for the first time, I've been saying smart dashboard, it's on the right auto mode every time, and we've never clicked anything. But now we need to click launch from side and stay. We need to switch to our other auto mode on that smart dashboard. And then we're in auto mode. Looks good. We already aimed it, so this is our test kind of anyway. So we're going to find out how it goes. Did I move the? No, that's pretty good. All right. Let's do this. 3, 2, 1. I looked this time too. It was like 3 seconds after the last ball launched. So we probably are good with more like 8 seconds of launching time, which is what we started with if nothing jams. But again, no harm in leaving it long. All right, let's talk about where those balls went. I think most of them went in, but there was definitely one that I think went short. So we're probably a little far away. So let's see. If 36 inches is too far away, I know I was saying like 30 inches was a sweet spot, so I probably should have just gone to 30 inches to begin with. Let's see. If we do 30 inches away instead, so we're going to get about 6 inches closer. Let's see what happens if we line the robot up on this line instead. All right, so bring it kind of up to that line, and then I got to sneak behind it to be able to aim here. And it is kind of tough. Like I'm aiming at the back kind of corner of the box. That's really the center of the goal. But my rotations made me be not 30 inches away. So we'll shove it a little bit. I think that's pretty close. Might be 30.5 inches away. But let's load it up again and try one more time. That's 6, 7. Is there one in here? And 8. All right, and there's no change to the code. I forgot to disable. You should always disable your robot. All right. Yeah, no change to the code. We're just seeing if this position is better. So let's run it. If anything, that might have been even more than 3 seconds of launching them all. I think every single one of those balls would have made it in. So what we can do now, I'm going to disable, but let's go to our code. And I'm going to make a note for this auto. Right, this is start from either side, aimed at the hubs, no balls driving. I can also leave ourselves a note here, which is start from either side of the hub, start corner of robot 30 inches from either side of the hub. That's our position for this one. And this auto mode seems about as good as we can make it. All right, let's add in another auto mode option now. So we've modified the options that are already in there. Now it's time for us to add a whole brand new one. And what auto mode do we want to do? Basically, the two auto modes we have are both the starting point for any additional auto modes, right? Because the first step in any auto mode we want to do is launch some balls. The second step then is, what do we want to do next? Do we want to try to cross the field and play defense? Do we want to try to get to the middle of the field and pick up some balls? Do we want to try to get to the human loading station to reload? Do we want to try to get to that, the extra set of balls on the floor in our zone and reload? So you kind of have those options of what you want to do next. And you want to kind of do one of them, because it looks like worst case scenario, right? We've used 11 of 20 seconds in this auto mode. And we could probably shave that down a little bit. We can probably make that be 9 seconds instead of 11, and the balls seem to always launch. Especially if we're going to get back and launch a second time, maybe it's not so bad if one ball stays jammed in the robot. So let's use that time. Don't waste that time. Worst case scenario, if all we do is we start where this robot is on one of the two angles, launch the balls, and then drive to the human player loading section, but don't actually load, that still saves us time in driver control mode. We're already there, right? So you might as well try to get there. And then if you can get there and you can drop the balls off, then you can try to get back. So we'll go ahead and add another auto mode for, it doesn't matter which one we're going for, either to floor load afterwards or to human load afterwards. But go all the way to the top. And we're looking for our different K autos that are here. And what we need to do is I'm going to add a line underneath. I like to keep them all together. And we're going to copy more or less the line above. So we're going to do a private, we're going to do a static, we're going to do a final, we're going to do a string. By the way, string just means that it is a string of characters, aka it's letters, it's words that we're using. And this is going to be K. Which one do we want to build up? Let's do K launch and human load. Right? Or let's see, wait, which way is which? Hold on. So we're here. If I go out to the right, that's human load. If I go out to the left, that's floor load. Do I want to crash into myself or crash into the cameras? Let's do floor load. I'll crash into myself. All right, so let's make this one K launch and floor load. Again, we don't have room in here, and we'll kind of like do a floor load template and a human load template, and we're going to have to dial those in when we get out to the main field with more space. Okay, it's going to be quote, all right, so this is going to be launch, K launch. We still have this from side or from the center. So this will be K launch side and floor load. So we're going to launch from side, then drive to floor load. And maybe we change this eventually to also say, and then drive back and launch again. All right, and so it's just like this. This line right here, you can add as many auto modes you want by copying this line, changing the variable name, which is this K whatever, and then changing the description. And again, we use this description again, so I like to keep it consistent. I'm just going to copy that. Oh, but this one has a period and the other ones don't. We got to grammatic consistency, whether it's right or wrong. All right, scroll down to the robot area. And here we have to do it again. So this one, mchooser.setDefaultOption. This is like that list. This is creating this with this list of select boxes or radio buttons. And the first thing you do is say, OK, the default option, if nobody clicks anything, is this. Then we're adding all of these other options that you can choose, and then we're sending it to the smart dashboard. So we need to now, every time you add a new one, we're never going to do a new default option, but we are going to mchooser.add option every time we need to add a new one. And then this is going to be the name. So this is what I want to paste in, but I need quotes on that, and I didn't copy my quotes. So we'll add some quotes. And then the second thing is the name of the auto mode. And this was K launch side and floor load. And we could probably make this variable name be a lot shorter because we always have this description next to it. But it's kind of not bad to be more descriptive when possible. All right, then let's scroll down. And now in this area, we have to make a brand new thing. So we can add this anywhere we want, except default should always be the last one. So I think the easiest place to add it is first. So if you go to the end of the switch after the open curly brace, we can hit enter. And then we're going to do a new case. And this is going to be K launch from side and floor load. And then you do a colon. And then enter, enter. And break is the end of this one. So like for our if statements, it's the start of the curly brace and the end of the curly brace. In this case, it is the case and break. OK, so now inside here, guess what? I mean, K launch from side, all of this is kind of the same. So again, I would take all this, I would copy it, and I would put it in here. And I actually am going to copy and paste this time. And if it helps you too, by the way, you can have spaces, I think, between the break and the next case, if that helps like visually see where your auto modes are split up. Man, that print screen button is right in the way. All right. So now we're working on this one. And the beginning is the same. We might, on this one, want to trim this number down so we have more time, especially if we're trying to get back and launch again. So instead of leaving this at 11, it might be worth it to trim that down to 9. We can also work on that later, changing that number. But we'll leave it for now. After we spool up, after we launch, we now need to not turn everything off. We need another else if. And our robot is sort of pointing in the direction we want to drive. Of course, I have to start on the other side. We'll reset the robot. But it starts on that angle. And if we just back up on that angle until we get the distance we need, then we can make one rotate and pull right into the floor load station or the human load station, whichever way we're doing it. So what we're going to do is we're going to say else if. And it's the same deal. We're going to do autotimer.get. And we're going to say if it's less than. And how long do we have to drive? I don't know. Let's say like if we were going to the zone, we would have to kind of get there and drive through it and get back and launch. So we really don't have that much time. Like if we did 9 seconds, we maybe have 3 seconds to drive there, 3 seconds to drive back. That would get us to 15 seconds into auto mode. That would leave us 5 seconds at the very end to try to launch again. So let's see what we can do with 3 seconds. We'll probably end up with a faster speed of movement than we want. And we might be able to trim that, this 11 down even more than 9. All right, so else, OK. If it's less than, 3 more seconds. So 3 more seconds after 11 is 14. So from 11 to 14 seconds, we're going to do this. All right, and what we have to do now is, first of all, we want to turn off our intake launcher and our feeder roller. So again, you could just copy it from the turn everything off page or section, or do it again, .set voltage to 0. And our feeder roller .set voltage to 0. And now we're ready for our drive. So we have to do a my drive dot. Remember, tank drive is what we were using before. And we want to drive forward, which we know is a positive value. We got to go kind of quick, though. So I don't know. Let's try I'm going to try 0.7. Which in theory is probably slower than we want to go, but also the robot's going to be driving at something and it's going to crash. So, you know, we gotta kind of balance that. We'll try to speed it up later once we have it kind of working. All right, so we're going to do that. Then we need another one, another else if. Sorry, let me go back and label this. This is actually, let's do 2 seconds. Let's do 2 seconds here. So this is drive forward away from hub until lined up with floor load balls. Because I said we had about 3 seconds to get there. This is only driving there. We still have to turn and then drive again. So we gotta knock that down a little bit. All right, else if auto timer dot get is less than, let's say we can turn in 1 second, 14. We need to be turning. So now again that we've turned these off, we probably don't need the code anymore, but just like before with the drive stuff, how we put it everywhere, I'm just gonna keep putting it everywhere. So we're always kind of sending a command to the motors. It's slightly better that way. You might actually see errors if you stop sending updates to the motors. All right, so now we're turning, which means we want one of these numbers to be positive and one of these numbers to be negative. So we're backing up. We're backing up to the left. So when we turn, we need to be turning. Oh, wait, no, we're driving forward. We're driving forward away from the hub because the floor loader is on the front. So we're driving away. We're going to need to turn left to then be able to go straight into either the loading section or the, to the floor loading section. If we were doing to the human loading section, we need the other side to be facing there. So for the human loading one, we would drive in and then have to rotate the long way around so that we could back in. OK. So the moral of that story was to get the floor load roller, the intake roller facing the balls on the ground, we have to turn left a little bit. And it is probably not a full second, actually. I'm going to update my guess to 1/2 of a second. So 13.5, right? Between 13 and 13.5. OK, and if you're turning left, it means the left motor has to be the negative side so that that side backs up and the other side comes forward. OK? Then I think we actually want to turn everything off at that point. We know we would want another step later. That would be drive the rest of the way to floor load the balls. But that could be affected by, we want to kind of get this turn good before we continue. So this is going to be turn to face intake to the floor load balls. All right, I think this is enough steps. Sometimes you don't want to add, like we added a drive and a turn step. Sometimes you only want to do one step at a time and tune that step in, because when you have multiple steps, you got to like pay attention to what's happening, and they can sometimes interact with each other. But let's go ahead and try 2. And that's why I'm not adding like, you know, the last couple steps or last step or 2 that might end up on there. So let's deploy this code. While that's deploying, it kind of doesn't matter if we start with the balls. I think we want some of the balls to be, you know, down here for floor loading. Now, in this situation, I said we were going towards the floor load, which means we would be starting here. Which is a little tough. Actually, wow, huh. So looking at this layout, right, if the floor load balls are here, and we keep with our goal is in the center like this, our robot is going to be starting like out here. Now, it's not quite perfect because the wall's in the way. So I'll probably shift everything over when we do this. But actually, just looking at this, the distance we have to back up is like nothing. We have to back up like, well, and I'm facing the wrong way. To not confuse myself. Right? So we're like something like this, actually even over a little bit. We only need to back up like a foot, and then we're ready to go. So yeah, we're going to change our code. But also, before we do that, let's right now pretend like this is not the goal anymore. Let's say the goal is like over here. So we actually have room. So I'm going to move the goal, what we are calling the center of the goal, over, let's move it over the 30 inches. So my mark at 30 inches over here, just for visualizing, that's the center of the goal. And then the goal is another, so this is the edge of the goal, would be somewhere around here. So then from our center to the edge of where you score, not the hub's a little wider, right? But it was about 41 inches. So if we go 20 something, this is now the edge. So basically the leg of this table is the edge of the hub is what we're looking at. So now, right, we would be something like this. Because we were 30 inches from the center. Okay, so 30 inches from the center would put our corner right on the old center. That had to be 30 inches from the edge of the goal, right? Yeah, because we said pretend this is the edge when we did it. Cool. So 30 inches from the edge, so it'll be 30 inches from here. Yeah. This would be a lot easier if you had enough room and you didn't have to kind of shift stuff over temporarily. So for this test, that is where the corner of our robot needs to be, pointing at the goal. That looks pretty good. And then, because we shifted everything over by 30 inches, these balls here also move over by 30 inches. So I'm going to move one of these pieces of tape about 30 inches over. So this is kind of like the start of them. And we're aiming more for like the center ball that would be somewhere here. So again, we need to drive this robot until it is like just here. We're looking at moving maybe 3.5 feet. So if we come back to our code, 2 seconds at this high speed is absolutely going to crash into my tables here. So first thing is, we're not moving as far. Let's keep the fast speed, but let's go really aggressive. Let's say like half a second at that speed maybe is enough. And then we said we were going to try to turn for about half a second. So because I changed this time, I have to change this time. So we're going to make that 12. All right, now let's deploy it. And in theory, we'll run the whole thing just because we want to see it working. But in theory, right, we don't actually need to launch right now. That's not helpful. We know the launching part works. We tested that because that's the code from the other auto mode. And plus, I don't want to chase the balls down. So in theory, I could actually make the launching time like 0. So we skip that step. So in the code, right, if we were really trying to tune in the driving, but we got really bored of waiting 11 seconds before seeing it drive, it would be fine to like 0 this out. Then we would spin up for 1 second and then just back up. So like we could make this not exist or be 1 second. Right? Then essentially we'll skip over this and just do our movement stuff. Of course, if we're doing that, we then have to subtract the 11 from all of the movement things. So it would be 0.5 and 1 down here, or 1.5 and 1 because we still have 1 seconds for the spin up seconds. So just know if you're going to test this a lot, you might want to do that just to get the driving stuff tuned in. But we've got our code deployed. We need to choose launch from side and then drive to floor load. And I guess we're ready to go because I'm not going to load the robot. We are going to have 11 seconds of just kind of waiting and staring at it. And I am going to be very ready to hit that disable button because I'm driving very close to things here. So we'll see how it goes. All right, we're ready. We're going to enable, and I have 11 seconds to get ready to click disable. Okay. I disabled it, but it had started turning. So the backup was actually pretty close. But we overturned by quite a bit, and we turned probably a little too fast. So let's make a small adjustment there. So I think this might have been OK. This turn, let's slow the turn down. Let's slow the turn down a little bit. Let's do 50%. A lot of times turns, even when you're trying to like rush and do a lot in auto mode, the turn being imprecise is a big problem. The more precise you can do the turn, kind of the better your life is going to be. So I'm going to slow that down a little bit. And if I slow it down a little bit, maybe we leave the time alone? Maybe? We'll change it a little bit. 11.9. All right. So now we back up for 0.5 seconds at 70% speed, and then we turn for 0.4 seconds at 50% speed. Let's just, and also, you know what? How do we want to do this? Yeah, I'm going to set this to 1 second. And I'm going to set this, instead of changing the number, so I can even leave myself a note, change back to 11. I want this number to be the right number. So the best thing I can do is if I subtract 11 from this, right, then that's like saying 1.5. And then I just have to know to come in here and subtract my minus 11s. Because if I had this at 0.5 and this at 0.9, it's not so bad to add the 11 back. But then when I get to like 12.2, then I gotta do math. And every time you're doing that, there is a chance to make a mistake. So I think it's maybe a little safer this way, but yeah, whichever way you want to go. All right, let's deploy that. And while that's deploying, we're going to set the robot back to its starting position. Seems good. It is kind of important too with this one, like when you're setting the robot now, like before when it was just like launch, as long as you're aimed at the goal, you could be here aimed at the goal, you could be here aimed at the goal, it's all going to work, right? But now, because we're driving, it matters a lot more. So instead of aiming at anywhere at roughly the center of the goal, I want to have a very specific aim. So I'm kind of like using the hood back here, the 3D printed pieces in the center of the wheel, kind of as a targeting thing. And I'm aiming, for right now, I'm aiming right at the center of the table leg, just so that I can stay consistent. But it is possible to measure your distance out and put this corner on it, and then measure out from the line and put that corner on it, so you can have kind of like those 2 points to try to be accurate as well. All right, let's do this. Launch from side and drive to floor load. All right, here we go. 3, 2, 1, robot. OK. Let's see what I did wrong. So it spun up, and then it got confused. So this should be, the spin up time is 1 second, and we didn't take that out. So I need to not subtract by 11, I need to subtract by 10. Right, so we're skipping this step, the launching step, but it's still 1 second when this one finishes, 1 second when this one finishes, so we need to be starting from 1 second to 1.5. So that should actually be this should actually be 1.5, so minus 10 is correct. Okay, let's deploy it again. This time it's going to work. Again, we waste some time here figuring it out, but we're going to gain a lot of time back not having to watch the launcher launch for 10 seconds every single test. All right, we're ready. Let us try. Here we go. 3, 2, 1. All right, that, let's see. We over-rotated, obviously we over-rotated. if I rotate this back to where it would be and follow it back here, this looks like we're going to be right on kind of the edge of the section. So like this ball is right, well, that was not a straight roll. This ball would be like right here. So that's actually not terrible. Like we wouldn't hit the middle of it, but it does look like we would pass through a full section of balls there. The issue is if we have a little bit more of an error, we want to be a little bit closer to the center. So I think we have two choices here, right? Like we got to here, we over-rotated to here. We could either back up more and then try to be straight on, or we could say this is a fine position to back up to, but instead of rotating straight, let's rotate just off of straight so we're aimed back towards the center of it and we'll hit the balls on a little bit of an angle. And who knows, that might actually be better for picking them up. So code. What this means is our rotate, which was for 0.4 seconds at 0.5, was too much by a bit. Let's try half the turn? Nah. Yeah? Let's try half the turn. All right. Deploy it. So now instead of going from 11.5 or really 1.5 to 1.7 seconds, or 1.9 seconds, we're going to only go to 1.7 seconds. And while that's deploying, let's realign ourselves. OK, looks good. Let's just get it running again. Autonomous. Launch from side and floor load. Enable. Well, that's actually pretty close. That's like straight on. Straight on maybe the second ball. So I don't hate that. I think I would reduce it just a tiny bit more. So let's do one more test, and then we'll call it good until we get out to the main field. So instead of 11.7, let's do 11.65. And we're going to deploy that one more time. While that's deploying, we, of course, reline up. All right, looks good. Close that, open the driver station, and let's do it. 3, 2, 1. Okay, the 0.5 seemed to change almost nothing, but I think that's good enough. I think it's possible if we start driving right away too, it'll end the rotation a little bit faster. So let's go back. Let's add our last kind of step here. And our last step, because we're just trying to floor load, we're not trying to necessarily get back in this auto mode. That might be, I might leave those steps for you to figure out. OK. Now that we're pointing this direction, we have to drive forward. So we have one more else if. So if you find, before I start, let's make sure we're in the same place. So after our turn to face the intake to the floor and load balls, we're going to do one more step. This is going to be else if. And this is going to be auto timer.get, of course, is less than. And let's see, the distance we have to go is about, assuming I set everything up right. And I can't do all of it because the last 2 feet are going to definitely crash into, well, maybe I can slightly move the table out of the way. So we need to go, to get to the very first ball, we need to go about 6 feet. And then it's another 2 feet to hit the driver station wall, which means we've gone through all of them. So 6 feet is, I don't know, I guess we're guessing again. Let's say if it's less than, so we're starting at 11.65. So if we did 1 second, it'd be 12.65. Let's see where 1 second gets us. All right, and then again, it's really all of this stuff. So I'm going to copy this from the previous step and throw it in here. Now, the intake roller, the intake and launcher roller, need to be on floor load mode, right? So what we want to do is intake voltage. Intake voltage is the voltage for floor loading for that roller. And our feed roller needs to be intake feed roller, intaking feeder voltage. Boom. So now we're set to floor load at this stage. So as we drive through the balls, we will have the floor loader going. And then our drive needs to go back to straight. And I don't know yet, because I haven't played with this robot a lot, like whether going really fast is going to be better to floor load the balls or going slow is going to be better to floor load the balls. So let's split the difference. I'm going to go 0.6. And again, your job might end up being like, how fast can you push everything? How much can you trim off the delays, off the timings, and how fast can you drive the robot and still be accurate if you're trying to get through the balls and get all the way back to launch afterwards. All right, let's deploy this. So I think this should end up short, but we'll see if I get scared. Reload the robot, set it up. All right. And I guess this is a good time to, I lost track of so many of these. All right. Let's throw a few more of these out here, because then, hey, if we can drive to it, then, might as well see what happens. All right. I don't think we're going to make it all the way there at this attempt. All right, let's see. We're good. Yeah, let's do it. 3, 2, 1. All right. We learned something. So here's what happened. The robot backed up and started turning. This time, it turned way less than it did last time. And that's because instead of starting the turn and then coasting a little bit more, it immediately started driving forward. So we need more turn to not crash into the table here. Now, of course, if you have more room, there's still lots of room on the field. We're not actually crashing into anything on the field. So that is the good news. All right, that looks about set back where we were. Let's make a change to that turn then. So this is good. All right, so this is turn to face. And turn is way too low. So it was 0.15 seconds. That turned probably half as much as we want. So I'm going to go all the way back up to 11.8. So that's saying a 0.3 second turn. And then the drive forward, if I want to keep the drive forward afterwards at 1 second, we need to be at 12.85. And this is going to be drive through the floor load balls while loading. OK. Send it again. And I will this time be more ready to disable the robot. Kind of got surprised that time and let it crash. All right. Oops. Closing the real log. And let's do this. 3, 2, 1. I have good news and I have bad news. We floor loaded balls. That's the good news. The bad news is it went way, way too far. And I'm not sure why. Did we forget to turn something off at the end, or what's going on? Yeah. OK, so in the code, I think there's actually a couple problems. But the first one is turn everything off does not say turn off the drive motors. So let's go ahead and select this line. I'm going to copy it. Let's paste it in here. And off should be 0 and 0. All right. So now we have the off there. And I made another mistake. Remember all these -10s? We need that here too. So it was actually driving for not 1 second or 1.05 seconds. It's actually in here driving for 10.05 seconds. So let's throw the minus 10 on here. I do think this can probably go up to 13 though. I think that's my guess. So we're going to drive forward for 1.2 seconds now. All right, let's deploy this. That speed driving through the balls worked really well. I know it was picking them up behind the table here, but it was definitely picking them up, and it sort of cleanly did so. I'll stack a few more balls there this time so we can get a little bit more of a feel for it. Let's get back to our starting position. We kind of also don't have the wall behind here either, so that would throw us off a little bit as well. All right, I think we're ready. We are on the correct auto mode, and let's do this. All right, 3, 2, 1, and okay. That's, I think, perfect. Hold on. That coasted right into the driver station wall. Now this time, we have another problem, which is no balls are inside the robot. We grabbed these two, but it didn't have enough time to pull them all the way in. Plus, there will be more balls in the back there that will be crashing through. So I think because we need the time, and because if we go in a little bit slower, we have more time to intake the balls before pushing them out of the way. I actually think we want to slow this speed down. And I think we might want, well, let's see with slowing it down. We might want another case that keeps the intake running a little bit longer as well. Just so after we hit the wall, it can finish intaking any balls that were partly in the system and get them all the way into the hopper. So let's do that. Let's actually increase the time that we're going to drive forward, but let's reduce the speed. So I don't know. I'm going to drop down to 4.5 maybe. We'll see. Unfortunately, that was a really good amount of driving. I have an extra period in here. That's why it's getting angry. Okay. And then let's do the other thing too. So we'll do one more else if. Else if auto timer dot. And of course, instead of typing the new else if, you could just copy all of this and paste it in. So the whole previous else if you could paste in. And this one, we want to stop driving. So we're going to set our drive motors 0 and 0. But we want to keep our intake rolling. And so if we're going to go till 14 here, let's let the intake roll for an extra couple seconds. 16. So 2 more seconds of intake running. Now, of course, in this case right here, if you were trying to drive back towards the hub to make another shot, instead of setting those to off, right, like the robot comes in, you can start backing up to start getting back into position. But we're going to just get to the loading on this step. All right. Yeah, let's send that. We might have to adjust our values a little bit more, but it should be pretty close. And then while that's running, let's reset the robot. And actually, what I'm going to do is let me take this crate. And I know we're just barely kind of still in our field of vision here. But if I put a few more of these balls down, and I put the crate here where the driver station wall would be, I'm going to kind of hold that with my foot. Probably you just want to make it a little heavier, put some weight in it, and leave it. But the idea now is we'll see if the robot hits that and how that affects its ability to pick up the balls. but we're ready to try, and I will be ready to disable if anything goes wrong. All right, and let's do this. 3, 2, 1. Okay, it's another good news, bad news. Everything worked. It ran the intake longer like we wanted it to. We got to drive a little bit farther. Not even much. Like, it's right at the start of the ball. So this 14, let's do, what do we think? Another half second, another 1 second. Let's do 14.5 because it's driving at me. I'd rather like creep up to the value instead of going past. And then that one has to go to 16.5, so we still have the 2 seconds extra. All right, deploy. And while it's deploying, let's reset. All right, another thing I'll point out too is it looks like we were like 12.6 volts before. Now we're down to 12.3. This battery is getting close to the point where it should be replaced, but I think we can do our last test here, or last couple tests here, and that'll be fine. All right, let's send it. Okay, so the delay was great. The speed was pretty good. We need to drive, or try to drive, another 10 inches. So we got one more tweak here, and that 14.5. You know, I think it's probably better to go a little bit too far because it is just the driver station wall there. Let's go all the way up to 15. Give it another half second. This one to 17. Let's deploy that, and then hopefully we're there. Do my best to I wonder how accurate they're going to be with lining the balls up, because like in all the field pictures it's like this nice grid, but they do not like to stay in place. All right, back to auto mode. Here we go. Enable. All right, so that time it bounced off the balls, off the wall, and then was kind of stuck there. So there is a world where we could make this number even bigger, and it might, get stuck on the balls, keep trying. There's also, if we really wanted to pick up the maximum number of balls this way, you might want to like back up, turn a little bit, and drive through it again a couple times. I don't know if you have time to do that and get back to launch them again. It looks like, I didn't have all the balls here, but it looks like maybe we can get 2 to 4, maybe 5 if we're lucky with this direction. You might also think about if you come in at more of an angle and drive the long way through them so the wall's not there, you might be able to pick up a few more. I think for us, though, probably we're pretty good. We might, when we go out to the real field and we have the bigger spacing, we might end up bumping up the amount of time that we're driving in to floor load. But the other thing we learned is that in auto mode, this is probably the worst option for what to do next, right? So we have kind of our two choices. Start here, or start here, launch, back up and get these balls. Start here, back up and go to the human player zone. Well, the human player zone, the balls all drop in from the top and there's more of them. So I think it's going to be easier to catch more of the balls here, and the time that you spend there is probably shorter in order to come back and try to launch. So I think if you wanted to work on one super extended awesome auto mode, I would probably do the side out to this goal, or the center back and then out to the human player zone. Probably the side is the easier one, right? Because you're already on an angle, so you can do that angle, make one turn, load up, drive forward, undo that angle, drive right back, and launch again. All right, so I think that's probably as far as we can go, in a reasonably constructive manner in the space we have. Now, when you're working in your space, again, if you can build some of the field elements and lay them out at exactly the right spot, you're going to be able to do even better than we were doing in here. But if you just have some carpeted area that you're doing this testing on, just do your best to make sure it's a big enough area that where your goal is and where you need to go, is all open. I would probably not put the table that you're programming and controlling the robot at in the path of the robot. That's probably not technically the safest place to be. But if you have that space, then spend more time now dialing that in. Choose those other auto modes you want. Remember that you can always go into the code and just add more and more auto modes to that auto chooser until you have all of the options that you want. We are going to kind of call it for our auto mode tuning right now because, again, of our space limitations. But when we go out to the field, we're going to have our last video here. We go out to the field and we test everything on a competition, well, not a competition field, but a full-size field where everything is laid out in the right spot. And we might look then at adding an auto mode to go to the human player zone. So we'll see you in that video. But once again, before we go, another special thanks to Argosy, First, Aramco, and Team 302, Lake Orion High School, for hosting our studio.